The age of 5G is here. By 2026, 5G networks will carry 54% of mobile data traffic globally. Industrial automation, driverless cars, remote medicine, video streaming, connected gaming, private networks. All of these advancements need speed, ultra-low latency, and scalability of next-generation networks. And they need to redefine network economics to be sustainable long-term. There's a need for a new network, open, end-to-end, cloud-native, automated. Mavenir is building the future of networks and pioneering advanced technology, focusing on the vision of a single software-based automated network that runs on any cloud. As the industry's only end-to-end cloud-native network software provider, Mavenir is transforming the way the world connects. Mavenir is the trusted partner to accelerate network transformation for 250+ communication service providers in over 120 countries, which serve more than 50% of the world's subscribers. MavCore, MavAir, MavApps, MavEdge, MavBiz, MavScale. The building blocks of mobile network technology, all on a web-scale NFV platform with integrated AI and analytics that can run on private, hybrid, or public clouds. These virtualized networks have the potential to lower CapEx by 40% and OpEx by 34%. CSPs reduce network cost, generate new revenues, expand enterprise offerings, and protect those revenues while building a new, agile, multi-generational network that's ready for 5G. This is the future of networks. One network, any cloud, all software. Trust the future. Mavenir.
What if you could build radio access networks differently, using fully open interfaces and the latest cloud technology? At Nokia, we believe in openness. It's part of our culture. We have been shaping open mobile networks for more than 3 decades. We are open to more. We are investing to make more open radio access networks a reality, faster, while ensuring that our customers' networks remain secure and delivering the highest network performance for evolving and new networks. We continue to lead radio access network innovation with end-to-end expertise and an open mind on collaboration. Nokia's Open RAN solutions support the robust telecom ecosystem that our customers and governments desire. We have been driving and actively contributing to the O-RAN specification. We are also the first global RAN vendor to join the O-RAN Policy Coalition. Now, we are leading mobile networks innovation in the next phase of open collaboration. Innovation for the benefit of a connected world. We are open to more.
"5G is driving a monumental shift in accelerating the digital economy and unleashing digital transformation. It's re-architecting your entire business and reimagining your role in the communications landscape. To thrive in a 5G world, you need the agility and scalability of a modern cloud infrastructure. But siloed, vertically integrated clouds and manual lifecycle management are slowing down your journey to modernization, decelerating service delivery, and cutting into your bottom line. The solution? Transform your legacy infrastructure with VMware Telco Cloud Platform. Our cloud-first approach unifies multi-cloud resources to reduce operational complexity, and cloud-native principles enable web-scale speed, agility, and cloud economics, so you can accelerate innovation and bring new services to market faster than ever before. VMware Telco Cloud Platform gives you consistent infrastructure from core to edge. It's designed with telco-centric scale in mind, like ultra-high performance, support for distributed sites, and the ability to service millions of subscribers. VMware Telco Cloud Platform transforms your network operations with multi-layer automation from infrastructure all the way up to services. It understands the unique network characteristics required for each cloud-native network function and virtual network function, so you can optimize your cloud resources to deliver new services fast across 5G from core and edge. Don't let legacy limitations hold you back. Begin your journey to 5G at telco.vmware.com.
With revenues from voice and internet data services plateauing, wireless operators are looking for new market opportunities as their networks evolve to 5G. Soon, wireless networks will have billions of connected devices generating massive amounts of data traffic, putting a strain on the network. If operators choose the traditional monolithic vendor approach, as the networks grow, the resulting staggered deployment scenario means operators will be held hostage to that vendor's closed and proprietary product roadmap. In this environment, new radio access network architectures are required that promote innovation through openness, programmability, and automation. To address these industry trends, Altiostar has developed Open Virtualized RAN, or Open vRAN, a software solution with open interfaces that can be deployed on commercial off-the-shelf hardware and run on a cloud platform. Altiostar leverages a diverse ecosystem of technology partners that enables operators to pick and choose a best-of-breed solution for their mobile network, rather than be locked into a single vendor. The Altiostar Open vRAN software platform provides mobile operators flexibility, performance, and scalability at a significant savings in terms of capital and operating costs. The Altiostar Open vRAN solution is a step towards realization of a true 5G vision. Services such as ultra-reliable, low-latency communication and Internet of Things will require massive scalability in the network. These demanding requirements necessitate the use of web-scale hardware and software platforms for the RAN, which is what Altiostar provides today. Altiostar was the first vendor to deploy Open vRAN at scale with the commercial launch of the Rakuten mobile network in Japan in April 2020. The company has also announced several other customers for its Open vRAN solution, including Dish as a greenfield new operator, as well as brownfield existing operators such as Telefonica and Bharti Airtel, paving the way for broader adoption of Open vRAN in the industry.
Start now?
Yes, sir.
Okay. Good afternoon, ladies and gentlemen. A warm welcome to the first technical session of the first event of Open RAN India 2021. The chairman of the session, Madam Deepa Tyagi, is with us. She is the Senior DDG TEC. Madam, welcome to Open RAN India, first event in India. Welcome to the conference. With over 35 years of experience in Indian telecom sector, electronics and communication engineer from IIT Roorkee. ITS batch of 1983. She worked in various capacities in DOT, Ministry of Communications, public sector units like BBNL, BSNL, MTNL. Currently, she is the Senior DDG and Head of TEC. Madam, once again, welcome to the session. I request the co-chairman Satish You log in, Satish. I saw him log in.
Yes,
Satish. Yeah, you're here. Okay. So Satish is the co-chair of this session, as Madam has to leave early. Satish will take care the session. Satish is the Vice Chairman of the TSI DCI and Vice President Reliance Jio. Satish, welcome to the session. I also request all the speakers to log in now. Rishi, Andy, Azhar, Marco, David, Sandeep, Nagendra, Arnab. May I request all of you to log in. Ranjit, all speakers are there?
Yes, sir. All the speakers are there.
They're staying. Now, this particular session is brought to you by Red Hat. So I request the Red Hat video to run now.
With the relentless growth of mobile traffic, the projected increase in IoT devices, and the massive potential of 5G and edge applications, communications service providers will see new revenue opportunities appear in the near future. To capitalize on these trends, service providers need modernized networks, flexible enough to tap into new market opportunities faster. Traditional radio access networks, or RANs, are expensive and difficult to upgrade and scale. Locked into inflexible infrastructure, service providers have difficulty delivering new services quickly to meet market demands and user expectations, even as their operating costs increase. Moving to a virtual RAN platform can change all of that. Red Hat's platform for virtual Open RAN can help you transform in 3 key areas: infrastructure, operations, and economics. With a secure, horizontal open cloud solution, the same platform can extend consistently across the network to support multiple functions and multiple vendors with small footprint and bare metal deployment options. Red Hat's solution is built on the open source foundation of Red Hat Enterprise Linux, Red Hat OpenShift Container Platform, Red Hat OpenStack Platform, and Red Hat Ansible Automation Platform. Red Hat offers choice. You can deploy network functions using containers, virtual machines, or both. Participating with our growing ecosystem partners as part of industry alliances means service providers can choose the best partner solutions to meet their needs with no lock-in. Partner container images are certified to run reliably and securely on Red Hat platforms. Red Hat Enterprise Linux provides key features that support RAN demands, including real-time kernel and support for precision time protocol and hardware acceleration. When you virtualize RAN infrastructure, you more readily get the benefits of automation and orchestration to simplify operations by streamlining end-to-end process flows, decrease risk through consistent and compliant configuration management, and achieve faster time to market for new services. Virtualizing RAN functions allows operators to pool resources across multiple cell sites and scale capacity dynamically to meet changing traffic demands. Service providers can also reduce facilities rental costs, power and cooling, and investments in servers and switches. These add up to boost long-term economic advantages. With a rich history of helping customers adopt cloud-native architectures, Red Hat's open-source technologies provide an agile, cost-effective foundation for innovation. Get ready to meet the challenges and opportunities coming with mobile traffic growth and 5G innovation. Your future is open with Red Hat. Learn more. Contact us today.
Over to Madam Deepya Tyagi for the address. Madam, over to you.
Good morning. Good afternoon, I must say. My esteemed panelists, co-chair Mr. Satish, all participants who have logged in today, ladies and gentlemen. My proud privilege to have been given this opportunity to deliver this introductory address on the occasion of first edition of Open RAN India Conference. Thank you, Bharat Exhibitions. Thank you, Sri Shashidharan sir. The subject is highly topical, relevant and timely, especially as we are about to commence our journey on in the realm of 5G. The 5G field trials have just been announced. In fact, 2 of our TSPs have just commenced their 5G pilot networks in Delhi, Gurgaon, and Mumbai, respectively. So I'm going to intentionally refrain from telling the benefits of Open RAN. Even the term Open RAN needs no introduction now. In fact, last night as I sat penning down my thoughts on Open RAN, I noticed that a lot of related terms that are floating around. You have Open RAN with space in between, then you have Open RAN with no space in between, then you have Open RAN with a hyphen in between, and then you have ORAN with no space, no hyphen. And then there are so many hashtags on social networks, and then there is VRAN, CRAN, XRAN forum, and so on. This can be very confusing when it comes to understanding which terms to use and when, especially for the uninitiated. Let me just quickly, for the benefit of our viewers who probably may not be familiar with it, Open RAN with a space in between, that is what is the theme also of today's conference, is not a technology. It is an overall movement in wireless telecom to disaggregate hardware and software and to create open interfaces between them. So it's not technology, but rather an ongoing shift from aggregated RAN to disaggregated RAN, from monolithic architectures to modular architectures. Then you have Open RAN, which has no space in between. So these refer to the 2 project groups within TIP, which is the Telecom Infra Project, which started in 2016 with Facebook and a couple of other partners. So this refers to 2 general purpose vendor neutral groups, the purpose of which is one of them is working on 2G, 3G, and 4G. And the other one, which is Open RAN 5G NR, that works on 5G NR. Then you have O with an hyphen in between and ORAN. Now this refers to the ORAN Alliance that publishes new RAN specifications. It releases open software for RAN and supports its members in integrating and testing of the implementations. Now, second very interesting thing that came to my notice as I was just penning down my thoughts was that Open RAN trials started in rural areas first. And India is a global epicenter for Open RAN. First Open RAN trials started in India and Latin America, way back in 2017. We may wonder why low ARPU markets became a playing ground for Open RAN. But clearly, India has participated actively on this journey of Open RAN since then. In 2018, Telefonica announced its Internet Para Todos, which was a collaborative project to connect the unconnected in Latin America. And in fact, they have now expanded their connectivity with an ecosystem approach, incorporating a broad range of partners and stakeholders to solve the rural connectivity challenge. I think in India too, with similar problem of rural connectivity and the challenge of connecting the unconnected, should embark upon such an initiative with active collaboration of some key players from the ecosystem. Then again, a question that comes often to our minds is, why do we need Open RAN movement when networks clearly use 3GPP based interfaces which are already open and standardized? Well, ORAN Alliance creates standards where none exist. Example, your front haul specifications. And where standards do exist, they help create profiles for interoperability. For example, like in the case of X2 interface. A leading telecom policy analyst, Fabian Webstad, had once coined a very interesting phrase, and I quote, "Telecoms is just software." We have ORAN Software Community, which is a collaboration between ORAN Alliance and Linux Foundation. Software-enabled Open RAN network architecture basically enables a white box RAN network, meaning that baseband units, radio units, and remote radios heads can be assembled from any vendor and managed by Open RAN software to form a highly interoperable and open best-of-breed RAN. Then, of course, there's a small cell forum with its own ecosystem of Open RAN with small cells in mind. And last but not the least, And the recent development is the Open RAN Policy Coalition initiative, which promotes policies to advance adoption of open and interoperable solutions. Now, why this Open RAN movement is getting so much of traction? Because truly the consensus is that RAN is 60% of the CapEx and OpEx. So Open RAN helps reduce RAN costs, and thus mobile operators can cut down their CapEx costs. But some of the challenges that Open RAN brings along with it are, for example, DevOps movement started in order to release software into production quickly and reliably, and most importantly, repeatably, for which they developed the continuous integration, continuous delivery, CI/CD methodology. But while these things have already been happening in enterprise and private networks, now they need to be made carrier grade. Mobile operators will need to implement CI/CD approach. Similarly, Open RAN introduces a very foreign concept to mobile network operators, a best of breed RAN. Now, though this is still a work in progress, basically moving from a completely integrated solution to a solution running across several products and partners brings with it huge challenges to integrate and validate and verify these solutions. And many times it is not important to optimize every component for optimizing the performance of the end-to-end service. So the real challenge is to understand up till what level you need to disaggregate and to what level you need to optimize each component. It is not necessary to be able to optimize each component to get an optimized end-to-end quality of service. Then the next big challenge that I see is integration and interoperability, and a mechanism to allot proportionate responsibility of quality of service and quality of experience between the different component providers. This will also be a challenging, because in the case of 5G area, where you have use cases wherein you require a lot of low latency and ultra reliable network. Now, in the event of a breach of an SLA, who's held responsible? Is it the telecom operator, or is it the integrator, the system integrator who integrates all the components, or is it the actual component provider? And how much of responsibility do you fix on each of the component owners for the total quality of service which a customer has been sort of committed to? So how do you fill the system integration, testing, and verification to create approved blueprints and reference designs so that operators can just go out and deploy tested, verified, best-of-breed RAN solutions? So we need to have a more uniform approach to systems, and integration has to be thought of. Now, with use of RAN, the number of network elements and interfaces which together constitute RAN increases, which leads to the doubt that Open RAN services may also have a greater threat surface. To make Open RAN secure, we will have to rely on trusted supply chain with vendors that have established security practices built into their engineering processes, and that those processes also have to be transparent. And more importantly, security testing may have to be integrated with published, well-known test plans at trusted lab facilities. So every element and interface would have to be auditable with respect to security, with greater transparency compared to traditional RAN. Of course, the flip side is that in Open RAN, when there is a network element which is identified as insecure, it is far easier to make a change in a modular interoperable architecture as compared to a network built from a single vendor. Now, as Open RAN is basically a new way of doing things in a very complex segment, some points that we need to sort of ponder over are that there could be huge interop and integration costs for the operator. For brownfield operators, there could be a problem in upgrading itself to disaggregated RAN models. So is the benefit of Open RAN only for greenfield operators? That we need to ponder over. Now, some of the new functionalities of 5G, like massive MIMO, mid-band and MM wave deployments, densification, Blueprints for these would also have to be put in place to build the confidence in the minds of the people. We need to ponder whether we have requisite hardware components that will be needed for supporting infra needed to underpin dense urban carrier class Open RAN. So basically, operators would need some proof points which would give them a comfort level that yes, by disaggregating software from hardware and from developing standardized interfaces and open reference designs, a flexible and a more agile network architecture is expected to construct and help operators save total cost of ownership. Now, Vodafone, every day you see new announcements. Vodafone has just announced a proof point wherein they have tested their 5G multi-vendor Open RAN infrastructure with RAN intelligent controller. Now, this is expected to sort of create greater acceptance of Open RAN in the industry. Among many research activities, RIC, which is the RAN intelligent controller platform, and corresponding XApps and RApps development are mainstream focuses and have attracted much attention from the telco community, although it is expected to dominate the market only by 2024 and 25. US Federal Communications Commission has already issued notice of inquiry on March 18th, 2021, seeking comments on the status of Open RAN, whether the technology is today and what steps can be required to deploy Open RAN becomes broad and at par. So FCC has already made this inquiry. The Government of India's Trusted Telecom Portal has also been launched yesterday, signaling the coming of, in effect, of the National Security Directive on Telecom Standards. The PLI policy has already been announced. So already Open RAN would have to be assessed and evaluated considering all these aspects. And we have a very impressive lineup of presentations today, and I'm sure a lot of these queries would be addressed in today's presentations. But before I end, I would just like to leave with some very thought-provoking questions, which I'm sure would be good food for thought. Now, some of these questions that come to my mind are, to what extent are these standard-setting efforts being driven by established large manufacturers? To what extent are these efforts enabling participation by smaller equipment vendors, smaller mobile network operators, and newer entrants to the marketplace? What steps, if any, should be taken by TEC or DOT to enable India to make a greater impact in the O-RAN standardization initiative? How do you leverage the vast expert of software talent that we have in the country and become a leading supplier of Open RAN solutions in the world? What role will system integrators play in advancing the deployment of Open RAN systems? Because it should not happen that through Open RAN, you come out of the clutches of a handful of conventional RAN suppliers and you get into the clutches of some big system integrators who would become extremely essential in the Open RAN scenario. So you have to see how best we are supposed to address these issues. Will operators and carriers execute their own integration as Rakuten has done, or buy hosted solutions from other providers? So we need to identify these gaps or potential bottlenecks in Open RAN ecosystem. Now, regarding startups in India, I expect that the discussions today would also address the following issues: whether Open RAN is likely to create opportunities for new entrants in the original equipment manufacturers market, whether, and if so, which aspects of the Open RAN architecture promote vendor diversity and competition, how Open RAN could encourage innovation by Indian companies, and how to anticipate, identify, and evaluate potential issues that might stifle innovation, manufacturing, and deployment. For example, is there a sufficient workforce in place with the training to safely and efficiently install Open RAN equipment in the market? If not, how do we generate such a workflows? How will access to intellectual property and patents influence the ability to influence? So there are a host of questions which we need to address. And the key challenge is that while there is a diversity of standards, because Open RAN it builds on standards which are spread across a whole lot of SDOs. So there is a diversity of SDOs, there is a diversity of vendors, there's a diversity of interfaces, there's a diversity of components, and there is a diversity of software solutions. And the elephant in the room with regard to Open RAN is, of course, integration, as some very senior research analyst at IDC had once commented. So the challenge is how to bring unity in diversity. Unity so as to create a network which is just as secure, as robust, as agile, and as safe, and as quality compliant as the conventional RAN equipment. With this, I would like to end. Thank you so much.
Thank you, Madam Deepa Tyagi. Thank you addressing the gathering. Now, I request Satish to chair the session. Take over one speaker. The first speaker is Rishi from STL. Satish, over to you.
Yes, thank you, Shashi. And the first speaker is Mr. Rishi Nandwana. So just a brief introduction of Rishi. Rishi has been involved with ORAN for about 20 years. And he's also worked in companies like Airtel, Aircel, and vendor companies like Cisco and Ericsson. Currently, he's working at STL and heading the RAN solutions focused on developing open virtualized disaggregated RAN. Rishi, over to you.
Thank you very much, Satish, for quick introduction. And namaskar, Madam Deepa. Thanks for your mentoring the complete industry on the ORAN. Very warm wishes to industry leaders, ORAN ecosystem partners, and my colleagues and friends. I am very happy to be part of this event today and feeling proud in contributing to ORAN growth story. ORAN is no more in infancy now. It is a commercial reality now. We are really thankful to the telecom operators across the world for leading the adoption of and providing the real evaluation opportunities for Open RAN players and driving this journey forward. At STL, how do we see ORAN, as Madam Deepa also rightly mentioned, that ORAN is not a technology in its right. It's a complete shift in paradigm, and that's how we also see the ORAN in the ongoing industry progress. Next slide. So if we go through the overall journey of telecom in past few decades, and many of our friends in this call and this session must be witness that, we started from the monolithic architectures. Everything was kind of coupled with each other, hardware, software, application, services, management, operation, everything was kind of coupled, right? And now we are thinking about open, disaggregated, virtualized, and the real truly scalable web scale architectures. That's where we are moving nowadays, right? Networks are becoming more open, disaggregated, and virtualized. So that's our perspective on the ORAN, Open RAN. That's the open, disaggregated, and virtualized, ODV. That's how we try to define the network in our way. Right? If you see the transformation of the networks in today's era, we are moving from the closed interfaces towards the standardized but open interfaces with the help of open standards. From the vendor-specific hardwares to programmable white boxes and monolithic and proprietary platforms towards the cloud-native and disaggregated platforms. These are the key natures of the disaggregation in the network. And if we talk about virtualization, localized control and data plane towards the centralized control plane, and then expensive systems from the TCO perspective to the better TCO, not only from the dollar perspective, but also from the value and innovation perspective. These are the key deliverables and key promises of Open RAN. if we go for little bit more elaboration of O, D, and V, the three characteristics of the Open RAN, the way we see at STL, the open standard provides us the open interfaces. So we are able to connect multiple systems and solutions from multiple parties, and still we are able to create it as a complete functional and full quality network using the open source codes. So we are opening up the platform for innovation, right? Now, innovation should not be limited to few numbers of companies or organization. Innovation should be given as a platform and opportunity to all the people who are able to do it in the best interest of the industry, best interest of the end consumer, and they are able to deliver it timely and of course in the cost optimized way. That's the promise of open source based systems development. It should be non-proprietary. All the interfaces should be standardized and open, so we need not to depend on one party, and align with the standards and deployed by open forums. We know, and some of our fellow colleagues have already mentioned some of the ecosystem facilitation is coming from a very like reputed organization like Facebook, Telecom Infra Project, the Linux Foundation, ONF, ORAN Alliance, where these are the collaborative bodies when everyone is coming to front and trying to contribute to make it really open but standardized architecture. When we go towards the disaggregation, the abstraction of hardware and software layer, the truly decoupling of hardware and software, which is the vision which is being realized as a part of Open RAN nowadays. Centralized control plane, we are able to keep the complete system intelligence and control at one system, whereas the user, one location, one server, whereas the actual user plane and data traffic is using the shortest and the best available path to provide the minimal latency and higher quality of services. Individual data plane, as I said, data plane can be decoupled from the control plane, and we should be able to define the service-based data plane routing, the quality-based data plane routing instead of the network architecture and interface-based data plane routing. From the virtualization perspective, we have seen, and many of our fellow colleagues must have witnessed the journey from the firmware to OSS. When once the OSS like Linux and Microsoft Windows came, we were able to deploy them on any kind of hardware. The people who have witnessed the virtualization of the core networks, once we were, instead of going to the monolithic architecture, we were able to go to the layered architectures, and we were able to deploy on the virtualized servers and COT servers. The complete core network can be deployed on those servers now. And same thing is happening here in the RAN networks now. In the radio access network, for good amount of time, they have been coupled with very specialized hardware and closed proprietary hardware. Now, with the software-defined networking, we are able to have those flexibilities of configuration, flexibility of deployment on non-proprietary and the standard COTS hardware. That way, we are able to achieve the optimized use of hardware resources and the pooling of hardware resources. That's the key here. And as we know, the traffic profile in the telecom network is quite very agile, and every few minutes, some of the cells might be low utilized, some of the cells would be overutilized, and the pooling of resources really gives us the good advantage of the best utilization of resources, not only from the capex and opex point of view, but also from the energy consumption point of view. And scalable on the go. These web scale architectures, virtualized architecture, if you want to grow, we should be able to grow in real time, almost in real time. We should be able to enhance the capacity of some part of the network which is getting overutilized. We can carve out the capacity from some part of the network which is low utilized. Those are the real advantages of using the open standard, disaggregated, and virtualized RAN. As I was saying, the Open RAN is not in infancy now. It's a commercial reality now. And the endorsement from the operators worldwide, and they are speaking this story. They are telling this story every day. Like Dish completes the successful 5G field validation, and STL is also part of that innovation which is happening at Dish. Rakuten has already shown good amount of results and performance gains in their real network operations and trials. Vodafone has a dedicated ORAN testing and the integration lab where they are providing a sandbox kind of opportunity for all the ecosystem partners. They can come here, showcase their innovation, and finally make more credible story for the ORAN adoption. TIM is also having their own contribution towards providing the lab for all the ecosystem partners. Airtel is also like very ahead in the innovation. They are also, last year they hosted the Plugfest, for Open RAN Plugfest. They recently announced a partnership with Qualcomm for virtualized and Open RAN based 5G networks. Globally, be it in Europe, be it in Africa, be it rural market, be it is the enterprise market, in all the market, we are able to see the good examples of Open RAN adoption every now and then. Now, if you see this journey, Open RAN is the journey which is just started, and it's a promisable journey. We see a lot of advantage of it. I explained some of those earlier, and I'm happy to give STL perspective on that. Transitions from traditional legacy RAN to the open and virtualized RAN, if you see it, the legacy RAN was being developed for 3G and 4G networks for a good amount of time, and there was some good amount of innovation in last 10-15 years there also in the split architecture, where my radio can go on the top of the tower and baseband units can be at the bottom of the tower. The baseband units are somehow somewhat compact in last few years, but still if you see the interface between the radio unit and baseband unit is still a closed interface, right? So there is a closed interface between RU and BBU, and these are primarily single vendor integrated models. So the innovation, the speed of innovation, and the overall the market positioning and the total cost of ownership to adopt those innovation is still limited by up to some extent. If you go towards the open, disaggregated, and virtualized RAN, we see the large amount of shift in the way we deploy our networks. The radios are more intelligent now. In the Open RAN paradigm, we are putting good amount of intelligence in the radio so that we are able to support the low latency services, high capacity services, and better controlled and more agile. The radio resource managements are more agile in these new intelligent radios, which are called ORAN 7.2 radios, or the other splits are also supported depending on the deployment scenarios. So 7.2x radios utilize the 7.2x split ORAN interface, which is between radio and the DU plane, where our low-fi radio front end and low-fi, these are the two major functions, are residing into the radio, whereas my hi-fi and other RAN protocol stack function, they are coming into the DU and CU. So radio is no more a dummy RFFE box now, it's much more intelligent box in ORAN paradigm. And it utilizes the open interface, so you need not to depend on one particular vendor. So this openness is the key of the interface between RU and DU. The disaggregation is the abstraction of hardware and software layer. We are able to completely virtualize the software for various protocol layers for RAN, not only Hi-Fi, but also the MAC and RLC. and also PDCP, SDAP, and RRC functions. The MAC and RLC functions, along with the Hi-Fi functions, those can be deployed on the DU box. Although there is a promise of using commercial off-the-shelf hardware for DU, however, it is still we still need to compete with the large-scale deployment solutions already available, high capacity and high quality solutions. So we definitely need some specialization in the hardware for DU. So it's just like on the GAN box, we need some graphical processing unit, same way on the DU hardware, along with the x86 or any other COTS platform, we would need some accelerator to fulfill the coding requirements, the high speed and low latency requirements of DU functions. So that's why we see it as a white box server with specialized hardware. Okay. And of course, software could be virtualized. Then comes the F1 interface, which is 3GPP defined standardized interface already. And that interface is between RLC layer and PDCP layer, where the CU functions, PDCP, SDAP, and RRC functions, those function in the virtualized function form, they can be hosted on any of the data center server or COTS hardware. So the advantage of openness, advantage of disaggregation, advantage of virtualization is offering the variance of multiple ecosystem partners who are able to have the focused innovation on radio, on DU hardware, on DU software, CU hardware, and CU software. And over and above that, we do have the complete software-defined network controller kind of application, which is RAN intelligent controller, which works as a kind of OSS or the oral orchestration and controller for the complete delivery chain of radio access network systems. So why should we go for Open RAN solution? What is the motivation behind that? The first and foremost motivation, I would say, is the innovation and the time it takes to get that innovation out commercially. That is the one of the foremost advantage I see. Aside to this, there are so many advantages which we should be able to quantify in terms of TCO and commercial qualification. So diverse supply chain with more number of ecosystem partners, more innovation comes, competitive marketplace is there, a timely marketplace is there, and then we should be able to reduce our go to market time, the rollout timelines, the agility to the traffic requirements, those are real good with the diverse supply chain. Better inventory management and utilization, this is one of the key aspects. With the open and the standardized white box architectures, you need not to depend on a particular vendor for capacity augmentation in some part of your network. The mix and match with the standardized interfaces is going to be the key. Suppose in one of the market, I'm using X and Y vendors for suppose radio and CUDU part, and tomorrow I want to augment and I do have a radio from the Z vendor, we should be able to deploy that immediately without even hesitation of any quality or operational constraints. More vendor competition, that definitely fosters the innovation, because that competition is not only from the cost perspective, it also goes from the value we deliver to our end customers. So that value delivery to the market is going to be a real good advantage of Open RAN disaggregated system. Best of the breed equipment. For every part of the network, the operators and telcos, they should be able to choose the best equipment. For one particular solution, suppose for macro solution, the radio from one vendor is best and the CUDU from another vendor is best, they should be able to take it. For a small cell ecosystem, we see the radio from the same vendor is not that suitable and we do have better choices. We should be able to go to the other vendor's radio without even worrying about the integration difficulties. Enhance security and agility. as mentioned by some of our fellow panelists, yes, the security is a concern in the open and disaggregated environment, but the standardization which is going on and the ITification of the this system, where the IT security aspects has been a good journey in last 20 years, and we should be able to implement all these security algorithms and security infrastructure with much more agility as compared to the closed systems. And the course deployment, commercially off the shelf, you should have, vendors would have the storefront. Then you can also have multiple type of hardware availability in your warehouses, like customer warehouses. We should be able to deploy easily, and we can support better TCO for telcos and operators. Aside to this, of course, there are some challenges also, and I would like to mention those also. The system maturity is one challenge. We started that journey, and that journey is not different from the journey we started for 3G, 4G technology for the legacy of vendors, right? We had first 3G deployment was a challenge. First 4G deployment was also a challenge. Similarly, the first few ORAN deployment would be having some challenges, but that's how the journey starts. And I don't take it negative at all. It's a positive thing. The traction we are getting into the market, that is giving us the opportunity to evaluate and identify the gaps in the system architectures. And we, along with all the ecosystem partners, we are collectively trying to resolve all those challenges. The complex system integration, yes, this is one of the key aspects. So this complete paradigm shift is going on. It has to happen now. The one OEM supplying all parts of the network to multiple ecosystem partners supplying multiple parts of the network, that's going to be the key thing. So the role of system integrator is going to be very crucial here. Probably it would not be wrong to say that the system integrators are going to be the front bidders to the telcos, and telcos can be assured on the system integrators as a single point of contact who can supply various part of system, integrate and deploy and operate various part of the system. So that is also one of the, could be one of the concern, but we do have a solution for that. The system integration ecosystem is developing very well. Security concern, as I say, yes, there are some, but the agility in the Open RAN and the software-based environment, we should be able to deliver the required software patches, required security algorithms as early as possible as compared to any other legacy partners and legacy technologies. At STL, we are, yes.
Mr. Rishi, in view of the time, can I ask you to summarize?
Yeah, this is the last, yes.
Okay, great.
Yeah. So at STL, we are very proud contributor to the ORAN community. We want to work with all the ecosystem partners to make it real commercial reality. And from the radio aspects, we do deliver, we do contribute in this ecosystem from the low power small cells, mid power radios, high power radios, and for indoor applications, outdoor application, all kind of deployment scenarios at STL, we are developing these and contributing in this ecosystem partner. In essence of time, I would end my story here, and I once again thanks Bharat Exhibition and all the community members to allow us to share our perspective on ORAN. Thank you very much, everyone.
Thanks a lot, Rishi. I think there will be a question answers session at the end of the presentation. So we can go to the next presentation right now, which is from Mr. Andy Stephen from VMware. Let me give a quick introduction. Andy, welcome, Andy. Andy Stephen works at VMware, and he is working on the Edge business unit as a product manager, and he's looking after the vRAN platform. He's been working with VMware for more than 10 years and various solutions focused on cloud platforms and networking. Over to you, Mr. Andy.
Yes, good afternoon. Thank you everyone for having me and the invitation. I'm going to explain today a little bit about what VMware is doing in the RAN market. VMware is new into the RAN space, not in the core space, certainly not in the new in the virtualization space. So I'm going to be explaining what VMware is doing from a vRAN platform perspective, and then how we're using this as a stepping stone to O-RAN solutions. So VMware is certainly not new in the telco space. As we can see from this picture here, we're seeing growing momentum. We have over 200 certified VNFs and CNFs that now can be deployed onto our VMware Telco Cloud platform. We have over 120 operators, over 3 million virtual machines deployed on the Telco Cloud platform. So strong momentum. But as I mentioned previously, new into the RAN space. But we can see from VMware's strategy here, VMware's strategy is to build a horizontal platform. And this horizontal platform can stand up and deploy resources into the network core. And we launched this last year. Can be deployed to the far edge for RAN use cases, and this we announced in April. And then later in the year, we'll be announcing the Telco Cloud platform for enterprise use cases, and also a Telco Cloud platform that will make use of public cloud resources. So you may be aware that VMware has deployments on AWS, Azure, Google, Oracle, IBM. And in fact, there's another 2,000 public cloud providers that have built their solutions on the VMware platform. And having this horizontal layer, which is common between all of these platforms, gives operators, real great choice, however and wherever they want to deploy workloads to, whether that be within private data centers that they own, or starting to make use of public cloud resources. And in fact, we're seeing it in the cloud space already, even though we've only been in the market a relatively short time, that people are already starting to make use of this horizontal platform and deploying resources like CUs into public clouds based on our platforms there. But today we're going to be focusing on the far edge and the RAN. So the VMware Telco Cloud platform for RAN is made up of three main components. So I'll give you an idea of what they do. First off, at the foundation, no matter where we do a deployment, we do the deployment on ESXi. ESXi is our virtualization layer. However, this is extremely challenging to deploy a DU workload onto a hypervisor. So we've done a lot of heavy lifting and engineering work to get the compute latency down to meet the stringent requirements of DU, to do the optimization, to gain the accuracy around precision time protocol. And we firmly believe, though, that having the hypervisor there gives customers the maximum amount of flexibility and isolation. And this can be really important, even if they're only deploying a couple of workloads to that platform like a DU. So having the ability to do operations and updates is far easier when we're talking to a virtual construct than when we're doing things on a bare metal platform. Tanzu is VMware's Kubernetes deployment. And in fact, VMware is the second largest contributor to Kubernetes globally. And we've done lots of optimizations here. We have a real-time operating system that has been developed to run on a hypervisor called Photon OS, and that is open source, but maintained and supported via VMware. We also have done lots of optimizations around NUMA placement, CPU pinning, CPU isolation, lots of stuff on the networking side, SRIOV, Mortis, Calico, all of these things that the RAN ISVs can then consume and deploy to. So this is the runtime, ESXi, and then Tanzu for the Kubernetes layer. But we didn't just want to come to the market with a runtime environment. We wanted to build in automation from day one into the platform. And this automation, as you will see a little bit later in the slides, deals with the automation of the infrastructure and CAS layer itself, but also allows RAN ISVs to onboard onto the platform and for the platform to optimize via pre and late binding processes. This means from day one, we deploy a generic platform, but when the RAN ISV deploys their CNF, the platform, in fact, optimizes itself for that particular workload. And this gives really great flexibility when we start to talk about O-RAN, of swapping out individual software vendors. That means that when we make the deployment, the platform is going to optimize itself for that particular workload. We take the workload off, it goes back to a generic state. We deploy a new workload, maybe a DU from a different vendor. That vendor can specify different optimization settings in a CSAR file, and then the platform is going to optimize itself for that particular workload. So at VMware, we certainly see the vRAN as a stepping stone to O-RAN. So if we look at where we are today, you know, this monolithic siloed architecture, well, we're firm believers of disaggregation, obviously using common off-the-shelf hardware, introducing an O-RAN cloud layer, which is this TCP RAN, but we still have the proprietary interfaces. So this is stage one. This is where we think we are today, realistically. O-RAN is when we break those interfaces, and we will also be introducing a RIC layer from VMware here as well. So we think the combination of having a RIC and the platform, we can have this closed loop where the RIC as well can make recommendations to the underlying platform to self-optimize. Could be things like you know, reduce power or deprovision workloads at certain times, have some intelligence around doing maintenance operations, this kind of thing. So an example of a deployment here. So in the far right-hand top corner, we have VMware Telco Cloud Automation. This is an instance in the most central place in your network. This can manage resources in your core, regional data centers, far edge, public cloud, and enterprise edge workloads. So this spans across everything. This, in fact, can then actually deploy out a regional data center. It's all defined in software, and we'll see that in the next slide. At a regional data center, we're going to have a more comprehensive stack from VMware, probably a fully software-defined data center with virtualized storage, virtualized networking. And here we are going to be running something called a VMware Virtual Center. And VMware Virtual Center looks after the ESXi hosts that are in that regional data center, but also looks after the remote ESXi hosts that are at the far edge. And then we deploy a Kubernetes cluster. In this particular example here, what we're doing is we're distributing this Kubernetes cluster in different geographical sites. So we're having the control plane sitting in the regional data center, and at the far edge, we're just deploying worker nodes. This means we leave as much scarce resource as possible for workloads at the remote cell site. This also helps with scaling and manageability, that we're just not deploying thousands and thousands and thousands. You can see how this number could really stack up of Kubernetes clusters. We can have you know, an object at a slightly higher level. Scalability is something that obviously we've had to think very hard about for RAN deployments. How do we scale up a solution to get to tens of thousands of remote sites? And Virtual Center itself has been doing this for a number of years anyway. You know, it's been doing some very large cloud deployments, be they within enterprise customers, telco or financial manufacturing, but also public cloud environments as well. So each virtual center server can support up to 2,500 ESXi hosts, And these ESXi hosts can be at remote sites, as long as there's 150 millisecond round-trip latency between the virtual center server and the ESXi host. That's absolutely fine. So 2,500 ESXi hosts per virtual, and then Telco Cloud Automation itself can support today 100 virtual center servers. You can easily see how we start getting up into the tens of thousands of RAN cell sites here. Now, I talked a little bit earlier of one of the key pillars of the TCP RAN platform is automation. And doing things in software, is what VMware is all about. So we have this concept of a site profile. And this site could be a regional data center, or it could be a far edge deployment. So we can build up within this Telco Cloud Automation what we want a particular site to look like. And then when infrastructure becomes available into the system, we can then tag it with that profile. So for an example here, I may have a regional data center, and this regional data center is going to be running a multitude of workloads. We maybe want to run NSX, which is VMware's software-defined networking solution. We may want to run vSAN, which is VMware's virtual storage solution. But when we come out to the far edge, we want a much leaner stack. Here, we just want to deploy ESXi and deploy this dispersed or distributed Kubernetes cluster. So we can specify this in software. And this then obviously gives us the advantage of we've got this standardization from day one. When sites come up, we can say, okay, apply this common standard of how everything is going to be laid out and deployed. It's all predefined in software. So you're going to have much greater predictability and stability through this. This also allows us to do updates in a much more controlled fashion. The second element of automation here is actually what we're doing with the RAN vendors themselves. So you may be aware on the core side, we have something called VMware Telco Ready certification. And there's over 200 RAN ISV solutions on there today, both VNFs and CNFs. We're extending this platform or this program to the RAN as well. So what does this mean? It means that VMware works with the RAN ISV, and we enable in the platform the dials, the switches, the knobs and levers that those RAN vendors need to set for their solution to deploy in the most performant fashion. So this means from a CSP perspective, if you have Telco Cloud Automation, you select your RAN ISV that you want to work with. They provide you a Tosca blueprint and a CSAR file. And this work has all been pre-validated with VMware and the RAN ISV themselves. So it means the CSP doesn't have to do all the heavy lifting and automation steps themselves. I can select the DU vendor of choice or the RAN vendor of choice, upload the blueprint, take the CSAR file that they provide that's got all the optimization settings in it, and then TCA will just then go and deploy it. So it's a watch this space. We want to grow this ecosystem to be as broad as possible. VMware has got no intentions of operating at the RAN ISV layer. We're firmly a platform player, just like we are in the enterprise space, but we want to be the best platform possible for these workloads to run on. So to summarize here, what we want to build is a 5G services hub or a mini cloud. So imagine, if you will, instead of having 10,000 sites that are just dedicated to RAN, we now have the flexibility that we can have 10,000 mini clouds. So we have the isolation that's required that we can run different workloads, be those workloads requiring different kernel versions, whether it's real-time kernel or non-real-time kernel, or different Linux versions. We can all run these things in a very secure fashion, have them completely isolated from each other. And this then means that in the future, we can look at applications that are going to make use of the low latency, high bandwidth that we're going to get from 5G rollouts to put RAN monetization applications out there, be they to do with augmented reality or immersive gaming or smart health or autonomous vehicles. You know, these applications that subscribers to the network will pay more money for. So we think this is a key way that we can monetize the RAN going forward, turn it from a cost center to be something that really can bring in additional revenue for RAN ISVs. So with that, thank you. I just wanted to give everyone a brief introduction of what VMware is doing in space. It's an area where we're seeing big growth. We've already got field trials in the US. We've got some field trials coming up in EMEA, and I'm sure we're going to be seeing lots more trials and rollouts in other locations as well going forward. So thank you.
Thank you. Thanks a lot, Andy, Stephen, for the presentation. And I think there will be a question and answer session at the end of the session. We'll go to the next speaker, and that is Mr. Hrs IST. He is the Global Chief Architect of Red Hat. And he's not present here, so he has a recording which will be played now.
Hello, thank you for the opportunity to have a conversation with you on Cloud Native Open RAN. Today we're going to discuss Cloud Native Open RAN as part of this Open RAN conference in India. My name is Hrs IST. I am the Chief Architect as part of the telco team here at Red Hat. Before we get into the topic of Cloud Native Open RAN, first of all, let's define what Cloud Native Open RAN is. Very quickly, Cloud Native Open RAN means Open RAN components, which is a set of disaggregated RAN components, RU, DU, CU, and so on, run on a cloud native platform. It just doesn't mean that they are virtualized or containerized, but it means that they're running as cloud native workloads on that particular cloud native platform. Now, the idea of running them as cloud native workloads essentially means they're adhering to the principles of being cloud native, which means they're intelligent and they're actually run as microservices and they're elastic and manageable. So with that definition in mind, let's first ask ourselves the first question: why Cloud Native Open RAN? New requirements for 5G mean that you need dynamic orchestration, adaptation to demand, scale on the fly, manage spectral efficiency, and tunability of RAN components to meet throughput, latency requirements for these new services that 5G is purported to deliver, which is ultra reliable, low latency, enhanced mobile broadband, massive IoT, and so on. Now, if you look at cloud is associated with elasticity, with flexibility, with efficiency, and scale. So disaggregated RAN components can then be deployed on commercial off-the-shelf hardware and be software driven and defined. So that means you can actually take a cloud platform or build a cloud native platform for RAN that allows you to use the benefits of cloud with respect to elasticity, scalability, efficiency, and so on, and put RAN components on top of that to make the RAN more adaptable, flexible, efficient, and dynamically orchestrated, which was the original requirement as part of 5G. So that's why we need cloud native for Open RAN. So then the next question becomes, what characteristics should this cloud native platform have for a successful Open RAN implementation? The platform must be capable of hosting, first of all, these RAN workloads and be able to scale according to these workloads and site requirements. Now, when you start to go deploy RAN, you're not deploying them just in one central data center, but you're deploying them near the cell sites, in your regional data centers, in your far edge locations, which means the requirements that they pose is very different. You need things like single node, multi-node, single cluster, multi-cluster, right? Distributed clusters, stretch clusters. So you need this compute capability and networking capability to be deployed in a variety of ways to address these RAN requirements. Also, this infrastructure must be capable of really addressing low latency requirements that RAN has. For example, if you want to run RAN DU, you need real-time kernel capability. You need hardware acceleration capability for forward error correction processing as part of RAN DU. You need to handle timing and synchronization. That's a requirement for RAN, because you're deriving timing from your clock sources and you're redistributing that particular timing across to other nodes in terms of the different timing profiles that there are. So timing synchronization to support things like slave clock, boundary clock is important as part of the infrastructure. And then this platform that's running on this infrastructure, which is general purpose compute commercial off-the-shelf hardware, should be an open platform. Why? Because if you're deploying software components from different vendors, should be able to mix and match these software components from different vendors to build an overall solution. So an open platform is important. Now, once you start to deploy platform in these locations, edge and far edge locations, you'd potentially be deploying other workloads there as well, such as edge compute, such as UPF for 5G core. Now, you could have a common platform that hosts some of these RAN workloads, as well as the UPF and some of the other edge compute workloads as part of the infrastructure. So a cloud native platform is important, and running RAN workloads in a cloud native way across a particular cloud native platform becomes incredibly important, as you would want to really deploy on the principles of cloud, manage that efficiency and all of the things we spoke about a moment ago. And of course, the platform needs to be able to manage a complete life cycle of the infrastructure and the workloads, and automate this capability completely from end to end, so that these deployments are done in a zero touch way, in zero touch operations way. So then the question becomes, okay, so all this is good, seems like it's possible, but what are the obstacles? What about costs? What about standards and interoperability? What's the maturity of this? Orin Alliance has done a great job of defining some of these interfaces, the front hall, the mid hall interface, and some of the other interfaces like the O2 for orchestration, E2 for RIC and RAN components, etc. Now these, and then there was interoperability testing being done in the industry via TIP, plug fests or plug tests, to actually showcase that different RAN components can work together. Then of course, because cloud native platform is being defined as part of the orchestration working group at WG6, you can then use now cloud native APIs to actually interface to the underlying infrastructure for observability, for telemetry, for tracking. So telcos are getting more and more involved, and there is now choice available to them from these different vendors, and it is maturing fast, as well as there is now interoperability. Now the question then becomes, okay, so what about costs? Well, numerous studies have been done in terms of costs. Maybe 3 years ago, it wasn't as cost effective because performance probably wasn't there and the workloads weren't really efficient at that point in time. Today, the answer is very different. Several studies have been done, and also some production deployments showcase some proof points that you can gain up to 37 to 40% CapEx and OpEx reduction if you go deploy cloud native Open RAN based on open components that are defined. Now, dynamic orchestration was one of the basic requirements we started with as part of 5G and RAN for tunability to address these different types of use cases and requirements. That is achieved now through addition of things like XApps and RApps with the RAN intelligent controller on that cloud native platform. So these XApps and RApps that you hear about, these are really microservices, and those microservices run on a cloud native platform. So what I'm really trying to say is the obstacles, the barriers are being lowered. There's now an ecosystem of vendors coming together to test interoperability and to showcase that you can mix and match radio components with RAN components and actually deploy on an open platform a full cloud native Open RAN. We know that RAN is all about scale. If you start deploying RAN and servers on all these different sites, how do you manage all these servers? Previously, it was devices. We knew how to manage them on a traditional infrastructure. Now you're talking about deploying all these servers in general purpose hardware. Can you manage them? The answer is absolutely yes. Yes, it is indeed about scale. Yes, it is scaling from tens of thousands to hundreds of thousands probably in terms of locations. And we are already seeing some of these designs being put together. How they are managed and how they scale is primarily because automation is playing a huge role in this. Automation of components, of lifecycle management, of provisioning with zero-touch provisioning, zero-touch operations is almost a must in terms of deploying them at large scale. Observability and telemetry with data aggregation and correlation becomes then necessary for you to automate and create a closed-loop cycle of managing these devices. So we've worked with our partners to create architectures that allow regionalized, centralized reporting mechanisms for manageability of these large deployment models. It's being done now in tens of thousands of sites. Not too long from now, they'll probably scale easily to hundreds of thousands of devices in this RAN. And these networks are live. Some of these networks are already live. So yes, it is possible, and yes, it is being done. But then, a common question that comes is, but wait, my requirements are very different. Especially in India, I have other challenges. How realistic is it for me? Well, this question is true for almost anybody across any geography in the world. Everywhere there are some unique requirements and there are some common requirements. It's about how you frame the argument. It's about how you actually design your system to overcome the obstacles that are there for you. For example, you don't need to boil down the ocean. You don't need to actually try to implement cloud native Open RAN in your entire infrastructure on day one. You can start small. You can, rather than take a one-shot approach, consider taking an incremental approach. Understand the value and experience the benefit, right? For example, starting small for Open RAN may be a very good idea. You can start in urban. You can use small cell as an excuse, build these small edge clouds, right? Host these RAN CUs. You don't have to do both RAN CU and RAN DU at the same time. You can just start to host RAN CUs on a cloud native infrastructure and still do RAN DUs as an appliance. And then when you feel more comfortable, go down to the RAN DU and extend that particular cloud platform over there. Lack of fiber and high-speed capability really is an issue. I understand that. And you do require some of this for Open RAN type of deployments. But you know what? Split RAN actually reduces your fiber requirements on the mid-haul. So if you start to deploy DUs closer to the cell sites, then your fiber requirements or your high bandwidth requirements are only limited to that particular front haul. And even there, new innovation allows you to use Ethernet for that particular front haul, Ethernet-based front haul. So things are changing rapidly. You can deploy using Open RAN components and reduce some of those fiber requirements as well, thereby actually providing better efficiency. You just don't need to implement it for LTE. You can do it for 5G new radio, or in fact, majority of that Open RAN deployment, what I'm seeing today, is actually being done for LTE. Now, as you start to introduce 5G new radio, you can actually introduce these components there. So then the question is, when do I do it? And where do I do it? Well, as I said before, start small, learn, and then grow. You can implement Open RAN using disaggregated components with LTE. You don't need to wait. If you don't have the spectrum for 5G, you don't have the components for 5G, do it with LTE. Do it for small cell. You can mix and match these components with appliances and cloud platforms. And over a period of time, migrate that into a horizontal cloud platform. Using open source as a way to define that particular horizontal cloud platform, where you can actually onboard workloads from different vendors and deploy that, allows you to scale for the future. Architect it, find the right set of partners, create those logical insertion points, find the right set of partners, work with them that have the same mindset in order to be able to innovate in this particular space. Really, all I can say is good luck. You should not, hesitate from deploying a cloud native platform for Open RAN, regardless of where you are, because there is benefits to be had. You can start small, learn, and then grow. Thank you very much. Appreciate your time.
That was a note from Mr. Hrs IST. We now go to Marko Babovic, Vice President and Head of RAN, Mavenir. Mr. Marko Babovic has been leading the Mavenir's radio access product management team, and he has been with them for about 20 years. He has about 20 years of experience. Prior to that, he has also worked with Ericsson and has worked on small cell initiatives. To you, Mr. Marko Babovic. And just to remind you, you have 15 minutes. Just try to be aware of the time. Thank you. We cannot hear you. Maybe you're on mute. Yeah, we can hear you now, but we cannot see your video. Yes, Mr. Marko, you can go ahead, please.
Can you hear me now?
Yeah, yes, loud and clear.
Can you see me as well or not?
No, we cannot see you. We can see your presentation, but
all right. Just give me a second. I will just. Sorry for that. You know, all these technologies, you know. All right, can you hear me now and see me?
Yes, both.
All right. Hi everyone. It really sucks to have to present like this instead of on a stage with looking at you and connecting to you. So hi, my name is Marko Babovic. I'm heading the RAN product management and Mavenir, and I will give you a glance on what the Open vRAN disruption is all about. Where are we at with it? Following the Mavenir journey, of course. That's where I'm coming from, and what to expect next. So, the first question is this figure. I will start with this figure. This is one of the figures I like quite a lot. It comes from Deloro latest forecast. It is a prediction or outlook on how large the Open RAN market will be in a couple of years from today. And behind this figure is the fact that Open RAN is now established, going through first few years of being shaped, deployed, and set up to stay. So there are no doubts about Open RAN anymore. There has been no doubts for a year already. So then, just to remind you on why is Open RAN disruptive. A quick view on the key components of the disruptiveness of Open RAN, just to start with. So years of consolidation towards just a few traditional vendors have led in shrinking the creativity and innovation by isolating the innovation towards proprietary hardware and very, very closed interfaces. Geopolitical restrictions didn't really help, and on the contrary, the amount of vendors shrinked even further. So Open RAN and Open vRAN is now disrupting this. You don't have one or two players anymore. You can select what part you want and mix and match. You can think about best in breed as a concept for you to build your networks and operate your networks. You can do that with Open RAN, and you cannot do that with a traditional approach, regardless of the interfaces that are inside. Then the innovation, just quickly touch on the innovation. The innovation is now unleashed. The possibilities are enormous. We have moved from as I said, closed environment provided with single companies, handful of companies, and single development platforms on the proprietary hardware to a development based on a much larger COTS and cloud design environment, which by itself becomes more and more platform agnostic with higher and higher hardware software disaggregation between servers, platforms, applications, and even allowing for specialized hardware accelerator cards to be designed as a component by many and used by many. And that's this is all about. Then what is another part of the disruption is the simplicity and transparency of pricing. That's becoming very natural. It's you buy a radio, you pay for the radio. You buy a server, you pay for the server. You buy the vRAN software, RIC, you pay for it. It's super simple. You don't have, it's a bad news maybe for procurement companies, but you don't have to, this is not an art anymore. It's just to find what you want, you buy it and you pay for it. Super transparent, no secrets, as Tarek Amin just said a couple of days ago. So then the pace of improving the raw hardware performance is then also changing. That's also a disruption. Changing from like 3-4 year cycle into half to 1 year cycles in Intel's example. The platforms are now doubling the performance yearly, and all this is shared with a much larger industry, not only telecom. So not only 4 companies. That's important to say. And it's not only about virtualizing RAN here. It's about virtualizing RAN and being open. Because if you virtualize RAN, you do get this Intel effect, but it's still proprietary on your solutions, and you don't mix and match. You don't get this. You don't allow anyone except your company to do innovation. And then the best of breed is becoming a single RAN best of breed choice if you are stuck with the non-open RAN. All right, so, but the question here is, these are kind of the main disruptions, disruptive moments, but where are we? And is this model going to work, and is it working? So how is the system integration, for example, as Madame Deepa asked? Actually, I liked her questions at the beginning of this session because they're really guiding all of us in answering. So, so it's a thank you for that. So how is this integration working with so many different components going to be handled and be handled? Who will secure all the parts fit together in a sustainable way? And I will just try to show you the story about where we at Mavenir have. So you can think about extrapolating to the ecosystem. But this is the Mavenir view. So radios first. In order to address a market, there is always the question on the radio band with proper regulatory approval, geopolitical compliance, and for a specific country and operator, right? Many are needed. Many radios are needed. Many are available as well, and it is a competitive environment. And we have gone a long way. Now we have integrated like 12 ORAN 7.2 radio platforms from different partners. They are not all listed here, and for both 4G and 5G, including our own radio product line that we started with. And the integration is just getting simpler, faster, and more automated. So, which means that last year it took us a couple of months for integrating the first platforms, right? But now it's like a week or two. That's what you need. So we are kind of automating that. There are clear instructions. There are emulators. There are email emulators, even not done by us, that are helping the radio vendors to be compliant, to design towards the ORAN 7.2, and then it's only the radio performance verification in the best case. So this is really going fast, and the key thing is that those radio partners are going into the fast system integration. That's the key challenge, and it is going very well. Then the server challenge is not the same. It's not about integration as much as it is to offer a good value for money and size. Don't forget that the competition is the challenge. The competition is in the proprietary baseband devices. So on-site DUs, for example, they demand a different set of options and configurations than the data center versions. And the specific layer 1 acceleration cards also demand optimized accelerators. With the Ice Lake and Mount Bryce from Intel, we have an established set of very, very good solutions already today. And more is to come, progressing towards a really competitive market. So the challenge there for servers is how do they get enough focus on Open vRAN? And we see a major change now. It's like it's a very, very different environment than 2 years ago. The servers are being tailored towards Open RAN, and there are very, very strong commitments on that. Last but not least, cloud platforms. I think we talked, VMware have presented the Red Hat before as well. The cloud platforms are already mature in the IT industry, so that's clear, and that's what we are reusing in telecom. That's one of the big thing. Now it is to apply all the innovation into another type of scale for RAN. The little extra thing is the on-site servers and the on-site like many servers somewhere else. That's the scale that we have to address here. And the challenge and the task for cloud platforms companies that we work with, you have a couple of them listed here, is to build scalable, affordable, and easily manageable platforms under the hood of RAN applications. And this is happening much faster than ever. And we, developer of RAN applications, are making sure that there is a simple portability across them. So we have just one set of RAN applications, not specific ones for different platforms. It's only one, and it is just portable. And this is real, and this is in place today, 4G and 5G. We have also our own platforms, by the way. So to summarize this, we have, from our perspective, we have many servers, many platforms, and many radios, and they all work together, and they are kind of orthogonal. So there are no dependencies really between the choices on the upper box, the lower box, the middle box. There are no dependencies there. Everything is organized and it's working, and we have major investments in continuous integration and continuous deployment loops to make this fast. So just then, where are we? This is one of the last times I'm showing this slide, and it is becoming really boring. But I will use this opportunity to say farewell to it. So it's quite simple. 4G Open RAN vRAN works well. It's stable for more than a year now. Let's move on. So, and then move on. What does it mean, move on? So the choice of components we talked about already, but what variety do you have with Open vRAN? Is this only 4G mobile broadband, or is it something more? In our example from Avenir, we have, as mentioned before, a stable 4G. We are filling it further with features, of course, and there is no magic there. It's hard work and focus on CI/CD engines, because that's essential. That's really essential to make sure things go ultra fast. There are a lot of investments there as well. But then 5G is very interesting from the aspect of being quite new, even for closed traditional non-open RAN technologies. There we are already pushing the boundaries for example 5G SA FDD for our customer Dish, where we are building their new nation 5G network. So it's like almost the first time that you figure out the SA FDD for field in a scale. And then there is a MSA and Massive MIMO and millimeter wave there as well. And all that is ready now, I have to say. So I have to say that for millimeter wave, we even invested in Mavenir, because there was no, in the ecosystem, there was no one really ready with millimeter wave. So we did the investment, and we know how to do that. And we prepared, I usually say, probably the best millimeter wave radio in the world, as this was lacking from the offerings from partners. And I'm saying, like, comparing even to the tier 1 the traditional vendors portfolio. So we started with 4G and added 5G and high performance for capacity systems. However, we decided to add 2G and 3G, understanding the reality, and there was a wide request from different geographical areas for preparing for swaps. I think in Telefonica presentation today as well, it was mentioned that you do change. You really want to change the site. The overlaying the sites sometimes doesn't work. So 2G and 3G is important, especially 2G. So we did acquire. We did do this through the acquisition of another company, IP Access, and are reusing their proven technology by containerizing. So we have, as I call it, one radio, one cable, one server concept for affordable multi-standard modernization ahead. So this is coming out now. So then, if I move to the common question, are we really ready in Open RAN? So this slide shows that we are, and it shows on the two kind of edge scenarios that are like technology-wise, they are really on the edge, on the radio side. So the newest and toughest technology is the Massive MIMO. In our example, you may understand where the ecosystem is if you understand where we are. We are actively working with 4 different radio vendors and we have ongoing trials with the tier 1 MNOs on the Massive MIMO. All this is in a true Open RAN manner. So what does it mean, by the way, true? Let me put it this way, a true Open RAN vendor is a vendor that is more than happy to work with anyone on the solution, consisting of mutual parts, even when they have their own parts. To feel for the whole broad environment, and that's the change. That's the difference. That's the difference is the model. Having the interface compliance is just a prerequisite. But if you stay as a single RAN approach with a very good Open RAN interface, that doesn't help. You have to have a wide and progressive business model to allow it. And we are trying to challenge so we can work with anyone from Avenir. We can work with the Nokias and Samsung anytime. But it's just, you have to have a bilateral at least agreements to start working on integration of our components in both directions. Our radio can be put on any vRAN software. Our vRAN software can work with any Open RAN radio. That's the fact. And not only that they can work, but we want them to work. We don't gain anything in Mavenir by having a closed ecosystem, only us and radios vendors. So just to conclude then, and by the way, I didn't mention the millimeter wave. I like it so much, so this is also a little bit of product marketing, of course, that I will use the opportunity. But this millimeter wave is a 6 kilo radio that is 62 dBm millimeter wave with 800 megahertz. So just think about those figures. Whoever is in the business will certainly recognize that this is unbeatable right now, and it's live. So to conclude, before I conclude, like, what do we look? What can we expect? What can we expect? We can expect that in Massive MIMO, what is interesting to follow and to see how it works, and what we believe will happen now, is the Massive MIMO deployments with the tier 1 operators globally. That will happen now. Then there will be a deployment as well. So many of those things are deployments, right? It's not like development; it's deployments. You have 3 deployments and 1 development item here. The second deployment that we can see is the ambition to use public cloud, such as AWS and others, after I would say settling the business models, right, between the different parties. So that's one thing that will happen now. Then there are new steps in the silicon development. that will make a big difference, and it will change a little bit the structure. The development is going faster. We have more powerful and more affordable solutions coming from several vendors, and that will actually give a very big boost soon. So those platform enhancements will come soon, and we will see the impact after. And last but not least, first millimeter wave deployments for example, fixed wireless access and for general performance and capacity improvements is something that will happen. And why millimeter wave is so particularly interesting, because it's also new for everyone, more or less, and it's also possible to actually add to the existing network. It's in an easier way. Let's put it like that. So that's a very exciting thing. So, and with this, I hope you have received the message what the disruption is all about, what is the status from our angle, and what will happen next. And just before I shut up, if you are wondering, is Open RAN ready? Please go for the facts and not for opinions based on defensive traditional four companies' values. We, through Open RAN vendors, are ready with. We are ready today with multiple standards, software portfolios, rigs on, best millimeter wave radios, great massive MIMO solutions, and a great ecosystem that is ready to deploy, integrate, operate, and scale. Thank you for listening. Back to you.
Thank you very much, Mr. Marco. So in light of time, we'll just switch to the next speaker, and that is Mr. David Raju. He has about 23 years of experience in the radio access network area, and he is the portfolio evolution manager in Nokia. Over to you, David. We cannot hear you. Maybe you have to unmute yourself.
Mr. David, yes.
Yes. Oh, okay. So, sorry about that. Yeah.
And can you be aware of the time? 15 minutes.
Yes. I have noted. Okay. Way forward with ORAN, and basically success in ORAN require industry convergence and partnerships. So let me start with this preamble. My name is David Raju, and I'm a portfolio evolution manager in Nokia. So this is the agenda I would like to cover. I would like to start with the ORAN architecture introduction and introduction to this ORAN various, openness dimensions, and then get into this ORAN adoption status. This has been discussed quite a bit even before. The former speakers actually talked about it. And so let's look at the ORAN adoption status. So it's actually not just about one aspect of the ORAN. There are several aspects to the ORAN, and maybe we can actually briefly touch upon what is the progress we have made in each of these aspects, right? And what are the challenges we see currently in the market? Mainly from a practitioner point of view, what are the challenges we see, right? And then how to get around the challenges? What are the best practices, both from a CSP's point of view as well as from the communication vendor's perspective? And we will also briefly touch upon what is Nokia doing with respect to ORAN. How we are trying to evolve the RAN network in various dimensions of openness. Okay, and we will also touch upon the ORAN deployment strategy. So let me start with the ORAN Alliance architecture diagram. That's what you see on the left-hand side. Here you see a disaggregated RAN architecture with open interfaces. And actually, Madam Tyagi made this point that ORAN Alliance is actually not trying to develop this overlapping specifications. They are trying to fill the gaps, and they are essentially borrowing or taking the 3GPP specifications as an input and enhancing these the interfaces to make them more interoperable. And again, we have this near real-time RIC as a major innovation coming from ORAN Alliance, and it provides this programmable interface with the E2. And then the core RAN function is realized with the centralized unit distributed unit and radio unit, and these network elements are separated with open interfaces. Of course, all these network elements are governed and managed by this O1, another open interface, which is providing the operability function. So, so this is the architecture, and let's see how this architecture is trying to evolve the RAN in multiple dimensions of openness. So that's what you actually see here in this middle column. Of course, open interfaces is mentioned. Open interfaces are important for evolution, but that's not it, right? You know, we also need the virtualization layer, and virtualization layer. Along with that, you know, we also need increased automation and orchestration. We also need the RAN to be programmable and data driven. It should follow a standard reference architecture, and it should also be developed based on this open source components, so that we can actually bring down the cost of RAN development. So, I mean, essentially, there are several aspects to this openness, and you can actually easily observe that each of these concepts, as such, are independent, but at the same time, unless we have a comprehensive strategy to develop a RAN network in a coordination, right, we will not be able to achieve the objectives which are listed on the right hand side. That is in terms of like achieving the business agility, right? In terms of like introducing a new feature of function much faster, or increasing the flexibility in the network. That is in terms of either like choosing, I mean, letting the customer and the operators choose different architectures, and also, you know, the vendor diversity, right? And all in all, it should provide the TCO benefit, right? Otherwise, it won't make sense. I mean, if you do too much of a slicing and dicing, the integration costs are going to be so high, finally, it won't even make sense. So with that as a context, so let's look at a typical adoption curve. So if you really see, I mean, maybe as I said, there are several dimensions to the openness, and the adoption curve for each of this dimension is slightly different. But all in all, if we speak, right, you know, maybe we are still in this early adoption phase as far as O-RAN is concerned, right? And basically in the marketplace, what we see here is still there are impediments. We have not really got into an early majority where there is a wide adoption of open RAN is happening. Why is it so? So some of the key challenges are listed here. Let me start with the first one. First of all, the O-RAN adoption is not uniform across the CSPs, and also it's not uniform across the communication vendors. In fact, like you know, some of the major vendors are not so keen with respect to O-RAN. I mean, essentially, Nokia is a major vendor. We are fully committed to O-RAN, and we are actually making substantial investments in developing the RAN network in an openness sense, right? But that's not the case with all the vendors, and because of that, you know, at least the market is fragmented here. Okay, and then there are three different points on this multi-vendor aspects. Again, actually, Madam Tyagi articulated this point extremely well. See, this multi-vendor integration is a non-trivial activity, and it is going to cost the resources. It is going to cost the cycle time, and especially if you're trying to introduce a technology, a new technology like maybe a 5G, obviously the risk of the technology risk is going to go up, right? And then, I mean, looking at the other 2 points, you know, especially from a feature parity point of view, it is much easier to achieve a feature parity across 2 different network elements if they are developed with one single vendor. But if the same thing needs to be done in a multi-vendor network, it requires a roadmap alignment. And we are already seeing, you know, when we started talking to the customers, when we started talking to some of the vendors, we see there are gaps, and there is a misalignment, and all this would actually take time to resolve. It is not that, you know, these are impossible things, but it would take maybe, you know, 1 or 2 years to get this alignment done, and only then we would be able to actually offer the customer the full feature parity. Okay. On top of feature parity, let me also talk about the performance parity. Right? Performance parity is even more difficult. Mainly because in a mono vendor context, there are always the proprietary algorithms. There is always an understanding between the distributed unit and the radio unit, which is like trying to maximize the hardware, right? And that will not exist in a multi-vendor environment. And that's the reason it is extremely difficult to achieve or match the mono vendor system performance. It is not impossible, but it is difficult to achieve, and it takes some time to really get to that stage. And another important point is with respect to this IoT profiles, this interoperability test profiles. Essentially, ORAN specification defines several profiles, and also the specification actually allows anybody to define a profile. And one can actually come up with an optimized profile, and they can start proposing it, right? So what it means is that there are several profiles out there, and it is extremely costly for the industry to implement all those profiles. And this is where some convergence is required from an industry perspective, so that we don't make the product development costly. And the last point, but not the least, is with respect to this ORAN specification maturity. And this ORAN specification maturity, of course, there's a lot of progress has been made, and especially in some of the work groups, a lot of good work happened, and we would be able to actually make progress with respect to product development. But still, there are gaps, and those gaps need to be filled, and this again takes some time. And once some of these issues get resolved, probably then we would actually cross the chasm, is what we understand in Nokia. So we looked at the impediments, we looked at the challenges. So let us look at like what are the best practices in the industry. Both from the operator perspective and also from the vendor perspective. At least what we are seeing when we work with this early adopters of Open RAN, some of these early adopters have sufficient knowledge, and mainly from a operator segment point of view, right? They have sufficient knowledge on this open interfaces and virtualization, and they are able to provide a strong governance, and they are able to actually facilitate and drive the multi-vendor alignments. And we think that such a strong governance, and again a continuous governance, is required for success of ORAN. And another thing is that some of these operators, again, they are factoring in resources for this multi-vendor integration. They acknowledge that the multi-vendor integration takes resources, it takes cycle time, so they are accommodating all these things in their project plan. Another best practice we have seen, very recently, we have seen 5 operators came together and they published an MOU. And this MOU consists of the prioritized Open RAN requirements. It also has an IoT profile. And so such initiatives really help us in a long way in making ORAN succeed. And coming from, and if we switch to the vendor side, and again, if we talk from a Nokia perspective, we are very much active in all the ORAN work groups. We are actively contributing to the specifications, and we are actually co-chair of 2 of the work groups, and we are actually trying to resolve this interoperability issues at a specification stage. And along with that, we have a wide RAN portfolio, and we are adding the openness as a layer. That is both in terms of like the open interfaces, and also in terms of like the virtualization layer. So we are adding this openness layers on top of the our existing portfolio, right? And we are also defining this IoT profiles, and we are proposing these IoT profiles to our customers, and we are taking their feedback and trying to optimize these IoT profiles, both with our customers as well as with some of the vendors. So with that, let me move to what is that we are doing in Nokia with respect to O-RAN. Okay. Again, you see this architecture diagram and how it is getting translated into different products. So let me start with this the service enablement platform, this common platform, which can actually host both the RIC applications as well as the mobile edge computing applications. Again, I mean, this can actually host both the in-house application, that is Nokia applications, and it is also enabled to host the third-party applications. So, and this is the one which provides this programmable interface or supports this E2 interface towards the RAN function. And coming to maybe the core RAN function, here again we have a wide portfolio of products with lots of flexibility. When, for example, we have an open fronthaul compliant baseband is being offered both in classical architecture as well as in cloud architectures. Because if we are maybe looking at some of the complex functionality and we are looking at, like, maybe increased performance, it is also possible to use a classical architecture to achieve those benefits. Or if we are actually looking at reducing the overall technology risk, we can always look at a hybrid deployment, both classical as well as the cloud together. All that is actually allowed with the Nokia portfolio. Nokia also has a wide radio portfolio, both from a macro point of view as well as from a small cell point of view, both from FR1 radios as well as from an FR2 radio point of view. We already have a wide portfolio. It supports various bandwidth combinations, and now we are adding the open fronthaul layer to all these radios, and we are trying to make them available to our customers. So what it means is that the Nokia radios would be able to work with a third-party baseband. Similarly, Nokia open fronthaul compliant baseband can actually work with the third-party radios, both in classical sense as well as in the cloud sense. Okay, so let me talk about. Let me briefly talk about this deployment strategy. Again, we talked about the various dimensions of openness, and we also talked about, like, we need a combination of this openness dimensions to derive the benefits, right? So here there are two alternatives listed here. Maybe one alternative is to actually go for a big bang kind of a deployment where we would put in the openness layer, maybe the open fronthaul, and we will also add the virtualization layer to it, and on top of it we can make it actually mono-vendor. I mean, this is probably the targeted deployment architecture. But then the second alternative is to go in a stepwise fashion, maybe go through this O-RAN inside use cases, where in every step we can actually create this performance benchmarks, and with that we would be able to compare, like, how the system is actually performing, both from a feature parity point of view and also from an end-to-end system performance point of view. We should be able to compare and correct and give it sufficient time for the technology to mature, and then do a multi-vendor network. And what we think is that, maybe it is prudent to follow a second approach, and Nokia as such, we are recommending, this O-RAN inside use cases. Essentially, I mean, this acts as an insurance for the operator, because the products as such would be compliant to the O-RAN, both from an open interfaces point of view as well as from a virtualization point of view. But the O-RAN inside cases would be the mono-vendor use cases. And once this technology is proven, and in the end, we should be able to actually switch to a multi-vendor network. So with that, I've come to the last slide. Maybe I'll quickly go over the important points. Essentially, alignment on this IoT profile is a key, and for the O-RAN to succeed, we need a robust governance, and as well as a continuous governance from the operators to align the multi-vendor issues. And we also need to acknowledge the multi-vendor integration cost as well as the cycle time. Industry has to converge on the open front hall requirements, and the strong partnerships is the key for VORAN success. And Nokia is actually working on all these various dimensions which I talked about in the presentation. And the last point is that it is maybe a prudent approach to go through this VORAN inside use cases before we get to a big bang deployment. With that, thanks a lot for listening. Back to you, Satish.
Thanks a lot, David. And we're running out of time, so we'll just skip to the next presenter, who is Mr. Sudeep, Vice President, NEC Corporation, and he has over 17 years of experience in the cloud data center area. Over to you, Mr. Sandeep.
Hi, am I audible?
Yes, you're audible. Please.
So my name is Sandeep, and I'm from NEC. And may I just request you to put my presentation on?
I think it's already on. It's your presentation is on.
I actually cannot see it, incidentally. Just a moment.
I can see it.
I cannot see it. Okay, I cannot see the presentation.
It will be a small icon in the middle. I mean, if you're missing it.
No, I just can see you, but cannot see the presentation. Okay, why don't I do one thing? Let me open it up at my place, and then let me take through the slide in the interest of time.
Okay.
So Sandeep sir.
Yeah.
You can see the whiteboard button below the presentation center. Whiteboard button.
Yes.
Hello. Just click on that. You can see your presentation. Done, sir.
Sorry. Yeah. Okay. Yeah. Thanks. So before I jump in the presentation, at this stage of presentation, having gone through multiple, maybe people have covered what it needs to be covered. But in this presentation, let me put as NEC, how do we see NEC in the Open RAN dimension? What are we doing? And interestingly, how do we see Open RAN? Whether we see it as a disruptive force, or where do we see a dominant force? So let me go to the next one. Slides are opening. Okay, so just a very brief, if I have to summarize everything what has been discussed till now, is what's the expectation of a typical 5G Open RAN would be? Well, it should be 4 dimensions. We should be able to create new revenue opportunities. Your architecture should support that. It should be healthy competition. It should not be a competition where only 3-4 people are playing. Ultimately, it's got to lead to a low OpEx. And it should allow for a very trusted vendor setup in terms of security mechanisms. Now, when I say that, and let's tackle each one of them one by one. And at the end, I will present where NEC is. But let me pick the picture. The first is revenue opportunities. So as we know, 5G is not only about high speed. We are talking about ultra reliable communication. We are talking about very low latencies and so on and so forth. What it does essentially mean to tap that revenue opportunity, your architecture should allow it. Your architecture should be virtualized, modularized, at the same time allowing a very service revenue based architecture. That would be the right expectation for anybody who is saying no innovation is for innovation's sake. Ultimately, we are looking for services, differentiated services, capturing differentiated revenue. So a typical expectation from an Open RAN architecture should be, it should allow network slicing, it should allow multiple layers to operate in, and it should drop in, drop out services at the extent what you need. So that's the first point, a typical expectation should be. Now, let me go to the next slide. And second is, any new technology, for it to become a very mainspread one, it should allow a healthy competition. You can easily see on the left-hand side, the moment you go to a disintegrated model, there's a play with multiple ecosystem partners coming in. So ultimately, any new technology like that should allow a wide ecosystem of vendors, because few of them name is very known as a system integrator, as a vRAN supplier, as a CUDU provider, and so on and so forth. And again, this is a bare bone expectation. If you go towards virtualized RAN, whether are you allowing the system to operate with each other? So that's the second expectation. Third, of course, low OpEx. Now, if you look at traditional, not a brainer, everything is integrated, your OpEx is high. The system should allow a cloudification of it. And that's when the right-hand side shows that everything becomes integrated. And if that's it being done, essentially you're allowing the architectural innovation is allowing you to achieve low OpEx. I would say in slightly longer term, but eventually that's one of the prime objectives. Now, let me go forward. Slide is taking time. Okay. Now, last but not the least, security. So there are two thoughts to it. One is, if you're breaking the architecture at multiple places, does it increase security loopholes? That's one way to look at it. Second way to look at it, because you are disintegrated from the core and you have multiple checkpoints, you can enhance the security. You're not directly hitting the core. So what NEC traditionally believes is that you're being best of breed of IT solutions. Now you have edge cloud and you have cloudification. You can bring multiple checkpoints and you can bring best IT practices to solidify the system. And hence what it means that our technology or OpenRAN should allow multi-layered security and a trusted vendor ecosystem. Now, till now, what I've actually covered is what should be the expectation. And it allow me to say that, if you make a transition from left to right, we will be moving from closed architecture to open architecture, from proprietary boxes to software, from telco site warehouse facility to a cloudification, and again, from a huge configuration, local, intensive site to zero-touch provision. And I think for all the four requirements, Open vRAN is the right answer. I don't think I'm saying anything new, but this is what fundamentally.
Are others able to hear him? I'm unable to hear him. So.
No, we can't. No, we can't hear.
Oh, we lost him. I was just thinking it's just me. So we'll just give it a minute. Okay. He's not coming back.
Satish, maybe we go to the next speaker.
Yeah,
Satish,
we'll go to the next. Yes,
yeah,
please.
Yeah.
We'll go to the next speaker.
Acha, yes, come back. He's back. He's back.
Okay. Yes. Sandeep, we still cannot hear you.
Can you hear now?
Yeah, we can.
Okay, sorry about that. Yeah. So now, again, to capture all the expectation from NEC standpoint, Open vRAN is the answer. And it's very interesting. The reason I say that, NEC has been in legacy, at least in Japan market, in 4G market as well. But as an organization, we think the real future belongs.
Yeah, again, we're seeing the same issue. Maybe we can go to the next speaker. Why don't we switch to the next speaker? Can we?
Yes, yes, Satishji, let's go to the next speaker. Yeah.
We'll go to the next speaker. Okay, the next speaker is Nagendra Baikampadi. He is the director of Product Management and Standards. in Altio Star, and he's been in the industry for over 24 years with a wide range of experience. And over to you, Nagendra. We cannot hear you, Nagendra. No. Can you unmute? I think you are unmuted, yes. Can others hear Nagendra? I cannot hear Nagendra.
No, we can't hear him.
Nagendra sir, can I request you to disconnect and join again, sir? There's a disconnect button, and then join audio.
Here, there's some problem.
Sir, it is a local problem at Nagendra sir's end, sir.
Hello.
Yeah, we can hear you. No.
Satish. Hello, Satish. Can you hear me?
Yes, I can hear.
Good. What about camera?
No, wait, sir. Wait. This session need to be over, sir. There are 2 more speakers in this session.
Can you hear me now, Satish?
Yeah, Nagendra.
No.
Yeah, thank you. Yeah, I had to change my speaker.
Okay, go ahead.
Okay, thank you very much. Yeah, let's speed up a little bit. So, the topic for today is security in Open RAN. Security in Open RAN by no means is a complete topic. So, what I would like to present today is the general status of what's happening in the security space, what's happening in standards, and so on and so forth. And hopefully, by the end of the session, people will have some concrete idea of what they can expect in this area. Now, let me quickly begin with Altio Star overview. I guess we can skip. I guess folks who have been in this call have already heard about Altio Star. Maybe a couple of important points here. We are in over 50,000 sites in Rakuten Mobile. And as you know, we are one of the Open RAN software suppliers. And we are also starting to take a very active stand in ORAN Alliance standardization work as well, especially in security and other areas. Now, the way I would like to structure the presentation is that I would begin initially with an introduction to RAN virtualization, and then also cover ORAN architecture in just a minute or so. The idea here is that when we start talking about security, it's important to understand potentially where the issues are coming from. So that is where this quick introduction is all about. So on slide 3, you see on the top half the traditional RAN architecture. You see all the baseband functions are at the cell site. Typically, what happens is that access network is considered untrusted. So when you connect this access network to the core, you would actually have a security gateway, let's say, on the backhaul, so to protect all the critical assets on the core network. In a traditional RAN architecture, the key point to understand is that the complete access network is considered untrusted, and operators typically take measures to protect the core network from access networks. However, when we evolve to when you evolve to an Open RAN based architecture, what you see here is that certain critical functions of the GNODP are now moved to the VCU, right? I guess the animation is not here, right? Is it a PDF that has been shared? Can I upload my presentation if that's okay with folks? Yeah, then I guess we can still. All right, never mind. Yeah. So I guess the key point here, folks, is that when I move certain key functionalities to the CU, to the data center, and protect that from a security gateway right here in the interface, you are actually converting that into a trusted entity. Likewise, you have layer 2 and some part of layer 1 being hosted on a VDU, which in the diagram here, I'm showing it as a data center entity, but in another topology, it could be actually located at the cell site. But depending on the topology, one could also argue that DU, the functionality that goes into DU is also somewhat trusted, at least in terms of, because it's hosted in a data center. And then finally, you have the ORU, which has the layer 1 capability. Now, two important points from a security angle here is that as the functionality moves towards the core, it becomes more secure, right? There are, typically we see that the VCU functionality is either hosted along with the management plane, meaning your EMS and OSS, or in some cases, it may also be hosted with the 5G core. So it is as secure as it can get from an operator point of view. And then what you also have is a security gateway, which is protecting your mid-haul, right? And then if the DU is in a data center, it also has physical security built in, right? So really in the diagram here on the bottom half, the most vulnerable component here is the ORU. And the ORU, I think folks who are aware of security would realize that the less number of entities that you have in a vulnerable spot, the lesser the risk you have in terms of security, right? Whereas in the top half, you have thousands and thousands of lines of code and multiple entry points and exit points, which would make it a broader attack surface compared to at least the bottom here. Having said that, nothing comes for free. You have this open front hall, right, which could be sometimes leveraged to launch an attack. But then we'll look at, as we move forward, what can be done there. Slide 4 is about the two topologies that I mentioned. The VCU is in a data center. On the left-hand side, the DU is also in a data center. Only the ORU is in a cell site, right? Whereas in the middle diagram, you see that the VDU is also hosted in a cell site. Now, each offers a different security, narrative, right? Here, you have physical protection that you leverage because DU is in a data center, and the only vulnerable entity, broadly speaking, is the ORU. Whereas in this case, both ODU and ORU are at the cell site, and there are certain catches that you have to be aware of. Of course, in the middle diagram, you don't have a front hall, right? While in this diagram, you have the open front hall that may be leveraged to launch an attack. In this case, you don't have an open front hall. So there are various aspects that we need to look at. This diagram here is about the ORAN architecture. What I would it's taking a little longer to refresh. Yeah. I don't want to rehash the ORAN architecture since we have already spoken at length about it. What I would like you folks to focus is on the diagram that I have my cursor on. ORAN has introduced a bunch of new interfaces. You need to remember that. ORAN has introduced a bunch of new functions. You also need to remember that, right? The other important thing is that ORAN is leveraging everything from TCP since it's built on TCP. So you really, all the activities that are going on in TCP, SAP, standardization, we leverage that. What we need to worry about is all these new interfaces that are coming into play along with these new functions. And as a security individual, when we start looking at the key issues, what kind of threats come, what is the risk, when we do a risk analysis, we confine our focus on these parts only. We don't worry about this. Okay. Now, with that, I would now move to security concerns typically raised with Open RAN. You see, there's a lot of discussion happening in the internet, right? You have the proponents, you have the opponents making certain claims, proponents trying to defend it. But objectively, if you look at it, from my point of view, these are the 5 big areas that are being raised as security issues. The open front hall between ORU and ODU, as I mentioned earlier, ORU is in a cell site, ODU is in a data center, and you have an open front hall. Open front hall is not like any other interface because you have constraints. There are some performance criteria that you have to meet. So there is a perception that open front hall, because there is no potentially there is no security built and it can be used to launch an attack. We also keep hearing about malicious XAPs in hierarchy rate, and I guess it was Azhar or somebody from Red Hat who made this point. XAPs is really a microservice, right? So I really don't see much of a difference in how a microservice is designed, developed, pushed through the registry into the production environment versus XAPs. Both these points, as I mentioned on the right, is being covered by ORAN Security Focus Group, where we are very active. Typical countermeasures include, protecting these interfaces, authenticating, authorizing network functions, and so on. And we will look at all of this in a bit detail as we move forward. The other two issues pertain to what I would broadly call as virtualization and containerization, right? People claim that by having hardware-software decoupling, you are actually introducing a new attack surface. And they also people also make claims that containerization might also be an issue in program. My quick take on that is this is not something which is not unheard of, right? Even if you take 5G, 5G core, for example, is service-based architecture, right? The same vendors who complain about virtualization and containerization, they actually supply 5G core service-based architecture, cloud-native compliant products to other operators. So it's not really something new that we're looking at here. And finally, there is also a concern that Open RAN has open source, and therefore open source will create additional attack surfaces. Again, my take on that is, I think it's a misconception to say that Open RAN is all about open source. Open source has been there in the industry for long. What has happened in the recent past is that people are now aware that there is open source, because there is this open source community work that is happening in ORAN. There is this push towards creating an open source compliant RIC, and so on and so forth. But again, to me, open source is an issue, but then it's not something that is specific to Open RAN. And we will also talk about a few things as to how to protect against that. When I look at security, right, to me, the three big enablers are what I have listed here as three columns. Yes, Open RAN Alliance claims that it is based on zero trust, it is based on never trust, always verify, and so on and so forth. But as vendors, when we start implementing, we also need to know main aspects that cover the security angle. First is secure communication between cloud native functions. I think it goes without saying, and that's what's been happening in standards for ages, right? You ensure that when entity A talks to entity B, they both know each other, they both are authenticated mutually, and they're authorized, and there is a secure connection between the two. What is interesting in the space of ORAN now is that because of the adoption of cloud native platforms and Red Hat, VMware, etc., coming into play, there is an appreciation towards adopting web-scale IT industry's best security practices for container security. There was never a discussion earlier, as far as I remember, on how you create a secure software. But folks, you need to appreciate the fact that now in ORAN, there is a big push towards creating secure software. So it's not just the interfaces, authentication, authorization. There is also a big push towards creating secure software. What does it mean to create a secure container across all its life cycle? And we will quickly touch upon it next. And the third important point is that again is coming to picture now is the security of the platform itself, where these CNFs are running. We will cover that. I would not spend too much time on this, I guess, because this is standard 3GPP activity, more or less. Anytime you have a new interface, you ensure that the two endpoints who talk over the interface, their communication channel is protected. And ORAN Alliance is putting in a lot of effort to use the best protocols that are available, namely TLS and NDS-IP. The two entities also are mutually authenticated using, again, the best available tools, namely X509 certificates. People have also suggested using SSH. In some cases, it's good and bad. I would not comment on that, but at least the push is towards using X509 certificates because you can then leverage the PKI that is already available and so on. And then finally, authorization. This is the typical ORAN security architecture I would like to always present because to me this covers all the interfaces and what's happening in that area. So you have the core, which we will not talk about. So you have the CU, CPUP, then you have the DU, then you have the ORU, right? And you have all these different interfaces. The interfaces which are colored in, let's say, light blue, there is already security defined for it. So, for example, on the mid-haul, F1C and FMU, and I'm taking 5G as an example here, 3GPP already recommends adopting IPsec, right? So there's nothing much for us to do. On the open fronthaul, which is like, to me, two biggest concerns people have is in the open fronthaul space. Second being, the cloud native. So in the open fronthaul, the MPLAN security is already defined. And by the time we hit the July release, we're also, hopefully, we are going to make TLS mandatory. So people can leverage all the best, open source TLS libraries to implement it. Where a lot of work is happening now is in the open fronthaul serious plane, and I'll talk about it in a minute. This is not an easy baby to solve because you have the S plane here, which is the timing and sync. It has its own caveats that you need to look at. We've also, this campaign is already covered. The table here introduces what's happening in ORAN, Alliance Standardization Group. The diagram, the color coded in green is all coming from 3GPP, and we're not moving to that, right? So that covers the event interface, XN, backhaul, and midhaul. Where a lot of discussion is happening since March, April of last year is in the space of open fronthaul and all the other interfaces, right? And also the accepts and RRs, right? There is not, we haven't really taken up work in RF accepts yet, but there is a lot of discussion happening in fronthaul and O1. And you will see that some recommendations are coming from the ORAN security focus group in the July training. Now, I would not be doing justice if I don't speak about the security focus group, right? Because it's as people earlier mentioned, it's a standardization body, which is owning the complete security and privacy of the ORAN network. So let's spend a couple of seconds on that. SFG is responsible for security and privacy, as I mentioned. There are quite a few high-profile, high-priority activities that are being worked upon: security for open fronthaul, security for O1. We are doing a very detailed threat modeling and remediation analysis work. Security testing framework is also being worked upon. One topic that is very near and dear to us is the open fronthaul security. And Artusar is the rapporteur for this work item in security focus. Say that while there are a lot of technologies that are being evaluated, what I think we have converged on is this last one here. What we will define in the July spec is that any node that connects to an open fronthaul network will be authenticated and authorized as per the 802.1x protocol, right? So you can be ensured that in a typical open fronthaul network with X number of RUs and DUs, switches and routers and gateways and multiplexers, an ORAN compliant vendor will have to support authentication based on 802.1x. So at a layer 2 itself, we ensure that these devices are, go from untrusted to trusted state. And you'll also hear some other recommendations coming over the course of time, hopefully by the end of this year. The next part, remember I talked about 3 enablers, right? So that was the first enabler, activities that are happening in standardization related to interfaces. Next, we will talk about what we can do in terms of leveraging IT best practices. This is a typical cloud native platform. I would not go, right? What I would like to focus here is how software that is, containerized, what kind of security processes it goes through, right from the build stage to the deployment stage. So that's what you see here. You create an image. Right? People have heard about CI/CD DevOps. What we do is integrate security into DevOps with the using security coding guidelines, the management, signed images, right? So all the images that gets created go through all these different processes and then gets pushed to the registry. In the registry, what happens? There are again standard security practices that one has to follow. You ensure that there's no image sprawl, wherein images start piling up and eventually it can be leveraged for attacking. You verify the images, right? Whatever image that got signed by the vendor will get verified by the operator at the time of deployment when it gets pushed to the production environment. And then finally, when we talk about deploy, I think Madam talked about CI/CD investment and so on. Very true. What the operators would have to do is to implement a CI/CD pipeline within their network, wherein they take all these images that come from the vendors. It goes through automated testing. It goes through all the image integrity, image scanning checks, and finally gets pulled by the orchestrator and then gets pushed to the cluster at runtime. This is a typical runtime environment that you would see. Okay, the screen is not flashing, but yeah, so you have the master node and the work node, and on the right you see a number of these different areas. Okay, is the screen coming now, or is it just me not able to see it? Okay, so there are four different. Excellent. Okay, yeah, so there are three, four different security angles that we need to cover. Unfortunately, this is not the the three areas are broadly, the host security, protecting workload with native Kubernetes security mechanisms, and then finally runtime security measures. I would not be doing my job today if I'm not stressing much on this runtime security measures, which is very important, and I have a nice summary at the end, which will capture it. So essentially, what this means is, as a vendor, we supply the image. It goes through certain security processes during in the registry, and then finally at runtime, you have all these different measures that one could do to tighten up the host operating system, to protect your workload using native security, Kubernetes security mechanisms, using namespaces, etc., and then finally you could use Kubernetes operators to do some automated monitoring and remediation. The last part of my presentation is about security hardening. There is absolutely no point in having a secure interface, right, or a secure software if you don't really harden the platform where you're running. Broadly, security hardening, again, this is not an exhaustive list. When you talk about how you harden the platform, you harden it during the software development process, which we've already talked about. You harden it, you take adequate measures in the registry. You take appropriate countermeasures in the orchestrator, right? So at all stages, right? Vendor, registry, and then orchestrator, right? And then at runtime, you ensure that all the required security configurations are implemented. You use automated tools to assess security configurations and guard against configuration drift. And then finally, in certain scenarios, not in all scenarios, but let's say in the case of CU, you could also implement hardware root of trust to ensure that bottom up, right, from the ground up, you have all the images that are getting verified step by step, and you build that chain of trust as you move up the ladder. I'll just expand on one topic here. Actually, I thought of doing two, but I'll just expand on one. We've already looked at enforcing security by design, right, using DevSecOps. What is also equally important is that you also have to ensure sanity of the image that is getting built using some of these following measures. There are no vulnerabilities. You ensure the configuration in the image itself is meeting the Center for Internet Security configuration recommendations. You ensure that images are scanned. A container workload will only run at the minimum privilege that is required for it to run. Right. So there are a whole suite of things that are recommended by this Center for Internet Security configuration benchmarks. So we have to follow all of that during software development. I would just highlight on this yellow box here, automated tools are very important to use to ensure that when a software is running and the management activities kick in and there is a lot of configuration changes going on, to consider. And then finally, last two slides. What would I call as key security differentiators, right? And I will just go through the left column. I think later on. Operator has full control to meet industry certifications. So the operator has control. Is it an inconvenience or a convenience? That is up to the operator to say. But definitely, the effort is worth it, right? You completely control what is being built. You have better enforcement of security controls in cloud infrastructure. And again, all this is based on SLA. The vendors have to meet. There, but you could not really enforce it. But now it gives you a chance to adopt and enforce. Adoption of industry practices and security of frontal. And again, I would not completely end this work because this work is still happening. But at least to me, compared to the olden traditional architecture, having a frontal gives you additional visibility, which will then enable you to put appropriate security mechanisms around it. Is the work complete? No, it is not complete yet, but we are working on it. And then the final slide is the key takeaway that I would like to present here. Overall security framework is built on hang on just a second. Yeah. So overall security is built on a shared security responsibility model. And again, I guess even Madam talked about it. The security responsibilities have to be very clearly split between the suppliers and the operator. And operator has a big role to play. Adoption of certain other key points which are not mentioned here is that adoption of cloud native principles is not new in the mobile network. Right? 5G core has already adopted that. Cloud security is also a very well established domain and constantly evolving to meet new age challenges. I think we can leverage a lot from that. Operators need to invest in security tools and automation in building their secure CI/CD pipeline before onboarding CNFs. That's very critical. If I'm an operator, I would put in a lot of effort in that. Runtime security measures to monitor and police traffic within the Kubernetes cluster is extremely critical. The day and age of perimeter security is gone. What you now have is a east-west security, where between Kubernetes pods you need to put firewalls, container firewalls to prevent lateral movement between pods. Misconfiguration is the #1 cause in the cloud industry today for data breaches. So you have to invest in automation tools to protect against configuration drift. And then finally, my recommendation would be that a system integrator would help in designing security. The system integrator may not be covering all the aspects, but at least a system integrator who is specialized in security would be a good investment for the operator to ensure that the network that they're building is secure, it meets all the required benchmarks, the SLAs are put in place, etc., etc. And with that, I would conclude my presentation. Thank you very much for your time. Over to you, Satish.
Thanks a lot, Nagendra. And we'll go to the last speaker, Mr. Arnab Das, who's head of Advanced Connectivity COE Capgemini Engineering. He has more than 30 years of experience in the communication domain. Over to you, Mr. Arnab Das.
Hi, I hope I'm audible.
Yes.
Okay, perfect. Thank you so much for the opportunity here, BHARAT Exhibition, and also all the esteemed panelists and very interesting presentations by Altistar right now on the security aspect, and VMware and many others, Mavenir, others. So I had a few slides which are a little more generic about ORAN and its importance and things like that. So what I'll do is I'll be skipping a few of them because this is towards the end. You've heard it quite a few times, and maybe focus on a few key learnings about deployment topologies and optimizations. Because ORAN is disaggregated, you can deploy it and make some choices depending on a specific operator's context. So we'll talk a little bit about that, and then maybe focus on a couple of aspects of system integration, how that can play a very critical role. And I think her colleagues or co-panelist Altistar just spoke about it earlier in the day. STL spoke about it, and others. So we'll try to talk about those topics a little bit. Moving forward, I'll skip this. Yeah, and essentially we've taken quite a bit of look at how this whole thing works in terms of what is the value proposition of Open RAN, and in fact we'll focus on a few aspects of how going from a more, I would say, contained radio network architecture, largely hardware or maybe single or a couple of vendor based, to a very disaggregated open network architecture, which is now possible. What implications it has on things like testability, things like vendor choices for the most optimal network, which can drive services at the lowest possible cost points, and so on and so forth. So, so I'll just go through some of these introductory slides a little more fast. Again, we've discussed, and most of the presenters, as well as probably the audience, is quite familiar with this. But some of the points here are rather important. For example, interoperability. Now, of course, we know about the Open Front Hall initiative, the interoperability between, say, the M-plane, interoperability that is required to bring together an Open RAN deployment where your SMO is able to work with northbound multi-domain orchestrator in a manner which gives shape to visions of, say, end-to-end network slicing. So what is the interactions that need to happen with the multi-domain orchestrator and the RAN domain or RAN domain controller interacting with that multi-domain orchestrator to enable network slicing, and which is very important from a telco perspective because that can be a important monetization tool. So all of these interfaces which have now opened up and multiple vendors solutions need to work end to end gives raises to some of the, I wouldn't call it challenges, but a conscious decision to take certain approaches towards ensuring interoperability as the networks are being designed and deployed. We just heard about, in the context of security, the software reliability and building thinner part separation through firewall pods and so on and so forth. So essentially that is, all of that goes towards the basic premise that open, disaggregated, software-centric network should be the one that allows a telecom operator, ideally, to reduce cycle time of feature releases or service releases or service enablement. So instead of doing it quarterly or even sometimes 6 months, you should be able to drive features out in the network and give services or address issues if that is the concern in a much faster cycle time. So how does Open RAN enable faster upgrades, and how does it's more amenable to doing something like CI/CD, CT, even integrated continuous testing pipeline. So those are some of the key aspects which I'm sure are very well understood today in the context of Open RAN. So moving forward, again, just a global picture of how the entire industry is. A lot of telco activities are centered around Open RAN nowadays. Obviously, Asia Pacific, the lead came from a greenfield operator, of course, Rakuten, but Europe is the hotbed today with several initiatives, forming consortiums, forming European Union-centric Open RAN alliances, which can really promote the technology of Open RAN and then maybe even do some technology development in that region and promote the rollout of this technology or migration, let's say brownfield migration from traditional RAN to Open RAN. So a lot of that is being done with alliances that, for example, Deutsche Telekom, Telecom Italia, and Orange have formed. Then, of course, Telefonica has its own global programs. Vodafone itself has been one of the earliest pioneers here in the forming the consortium under TIP, and then TIP and Open RAN Alliance partnership, if you will, with driving programs like the Radio Intelligence and Automation, the RIA program, so on and so forth. So US is also catching up. A couple of operators, especially some greenfield operators, is also becoming quite active and very much public, for example, Dish. So bottom line, it's a given now for most telcos, especially tier 1 telcos, to have a very firm view, and of course, within the context of the telco, pace the adoption of Open RAN, but certainly most telcos are very much deep into the cycle of having Open RAN strategy and forward look plans on how they want to launch the network. And again, this has been quite a bit talked about, but this still kind of spending a few minutes on this to really highlight a particular aspect here. Yes, the network is completely disaggregated. We've heard everybody talk about several facets of it, the radio unit, the distribution, the distributed unit, the central unit. The fact is that you can now pick and choose almost any one of these blocks on this diagram and decide to create a topology. Of course, it needs to follow some of the constructs, the option constructs, and the separation of high-fi, low-fi, and several other aspects that the ORAN Alliance is standardizing, if you will. One important aspect here, and we kind of heard about that from the presenter from the start earlier, is because it is now software almost everywhere. Of course, it does need the participation of hardware on certain things like the MIMO performance and how your L1 is behaving or how the L1 functions. Having said that, due to the presence of software, pretty much from L2 upwards, it means that while it gives you a lot of flexibility, which means you can create applications, you can launch services, you can create business vertical slices, you can create optimized view of the network for certain types of subscribers. All this flexibility comes into the network because you have larger presence of software. You can address network performance issues. You can make the network very flexible, which means if you have an AI/ML engine and a certain type of XApps running within your RAN, you can design the network to scale up to meet certain traffic requirements. And when the traffic patterns allow it to actually reallocate the resources if the traffic patterns are not commensurate with the resource that is allocated. So which means you are making sure that you're not either overutilizing or underutilizing resources. So all of that capability comes in because essentially all these components, especially from DU onwards, is very much software driven with network exposure functions and ability of intelligent applications to use those functions to really program the network on the fly. So this is an important facet, but it also means that a lot of due diligence has to be put in as to how these APIs are consumed and what kind of applications you allow to be running in the network and what overall impact it might have. Some of the deployment choices, again, because the network is disaggregated, it means it gives you a lot of choices in how you can distribute the network in your deployment. Where do you locate the DU, for example? You can locate it, co-locate it along with the RU and remote site, or you can have a front haul interface. You can have literally distributed DUs, and then that goes into a centralized CU. Or if the network allows, you can really have the CU DU centralized and really your radio units distributed. Now, there are several aspects of how a telecom operator might specification allow all of this. So, for example, if the fiber infrastructure, especially high capacity, very low latency fiber infrastructure that is needed to drive the front haul, because this is where your radio functions, very time sensitive radio functions are traversing the node between RU and DU. So if the fiber infrastructure is available, then you could choose what you see here is an option in between, which is RU front haul and mid haul, which is more of a classical, I would say, 7.2 architecture. However, if the fiber infrastructure doesn't allow you to really port, because this front haul can be quite expensive fiber infrastructure, then you can co-locate the DU and RU, and really the mid haul, which is not as stringent in its bandwidth capacity and latency requirements as compared to the front haul. So you could have a lower cost access or transport infrastructure which can perform the mid haul function. So what the key point here is the technology, the architectures, the standardization approach that is already available does need transformation in the context of a certain geography, in the context of a certain telco's current operations, to really come up with what's the best possible configuration. How do you build and deploy this network, which makes not only service sense, which means the customer experience of the network is good, but also it makes the TCO and operation cost and so on and so forth sense for the telcos. So that means this is a facet of the openness and the disaggregated nature of the network that now needs to be also baked into any kind of Open RAN network rollout plan, design, build strategies that others may have. This is just a little bit more of emphasizing the point, if you will. If you see here, the key theme is you've got 3 planes of interfaces, and many of my predecessors really talked about this in great length. So you have the most sensitive, where the data travels, user plane. And then, of course, you have the control plane, the brains of the network, which is doing all the coordination. And then you have the management plane. And in fact, there is another plane, which is a synchronization plane on the front hall. Now, what does all this mean? That literally, if you can have multiple vendors for each of these boxes. And between these vendor equipments, of course, that may not be depending on certain criteria, you may choose not to do it. You may choose to select vendors in certain groups. For example, CUDU from somebody, RU, you can disaggregate, or you can literally have a completely disaggregated multi-vendor network choice. But it also means that one needs to focus on how are these interfaces, how are they working? Does the sync plane work between a disaggregated network where the RU is coming from one vendor and the DU is from another vendor? How does the orchestration work? If you see here, the SMO and the manner functions, you could potentially have the network orchestrator from one vendor and the RAN controller being provided by another vendor. So you need to test out all these interfaces. And then, of course, as we just saw, each one of these interfaces, one needs to look at it hardening from a security standpoint and do the certification and recommended tests that need to be done to ensure that you really come up with a network which is truly deployable. Of course, the initiatives like the OT or the IoT work group specification for front haul testing from a standardization perspective is making very rapid progress. So even from 1 year ago, between now, the number of profiles that are available, the test vectors and test suites that are available to test out all these interfaces have improved. But all of this needs to go into a very robust network design and integration, system integration strategy from a telco perspective, which really is something which is very key to the new open network, if you will, that Open RAN kind of brings to the table. And this is where we come into how this is maybe a little too simplified view of the traditional network planning, designing, and traffic engineering for traditional RAN versus how all the pieces of the puzzle need to come together when you look at Open RAN and where the system integration activities play a very key role. But the real point here is all of these equipments need to really come together. We heard from Red Hat and VMware earlier on the infrastructure as a service or CAS layer that they provide and how it is optimized for certain hardware functions, which is doing maybe the DPTK or the user plane or SRIOV functions where the hardware and the CAS infrastructure on which the workloads of Open RAN run. So all of those, first of all, making those combinations choices and then ensuring that all of these pieces come together in a staged manner to create one particular pro forma or so-called blueprint, which is a much used word today, of the network, which a telco can benchmark, create the operational cost model for this particular blueprint and make its own choices to say that, okay, this is something which I can deploy in rural environments. This is something which I can deploy in tier 2 circles. This is something that this is a blueprint that needs to come together and perform for me in a dense urban metropolitan environment. So a lot of the pre-work really has to go in, and a lot of telco strategy, many of the, as might be quite commonly known now from the industry intelligence, many of the telcos, both in Europe as well as in Asia Pacific, EMEA, are currently, they have a very good view of the vendor ecosystem. How does this all come together? And therefore, they're focusing on all these RFIs and RPs that are in the market today from a system integration standpoint. How does all of these come together? Where does the accountability of the network performance sit? And what will the system integrator own versus what does the vendor own? So all of these issues are being addressed, and more maturity in the thinking process and the transformation that needs to happen in the business processes of network planning and service planning is coming together. But it is a complex problem as compared to a little bit of maybe simplified and well-established processes of the past of how the 4G networks were probably designed and early 5G NSA networks were rolled out versus more of an open RAN based networks that are definitely being planned and for deployment in today's context, and more of this as time goes on. Of course, now there is another facet. We talked about disaggregation and democratization of vendor ecosystem, and we talked about how the interfaces have opened up many more permutation combinations, testing interfaces from vendors. And we also talked about how it is software centric. So the whole process of workloads coming in from CU vendors, DU vendors, orchestration vendors, getting positioned on the CaaS or container as a service infrastructure intended for the far edge, aggregation edge, or data center or regional edges and national edges, so on and so forth. So all of this we talked about, but there's another facet to this, which is also many of the operators are already working quite actively on this, and we are engaged as Capgemini in several of these conversations, both from end system integration solutioning as well as organization transformation. So as you can tell, with more and more software, and somebody I think quoted also that take the best practices of IT, because the IT infrastructure, the enterprise bus, and the migration of IT into containerized applications has happened, which means the workforce, the business processes of how the network is designed, tested, deployed, managed, and operated, and how the DevOps pipeline runs on this, and therefore what is the implication on the organization, what are the skill sets of network operations people, what are the skill sets of network design and test organizations, a staging organization within a telco environment. So there is an element of organizational transformation also, which may not be that obvious when you look at just the Open Alliance and all the technology aspects of it. But when you think of it from a telco standpoint, many of the telcos are also considering some of these aspects and how to take up this journey, and some are quite advanced in this and from a transformation perspective. One topic that usually comes up is, so who take in a multi-vendor environment, who takes up the responsibility of the SLA? How does the chain of SLA command, if you will, work? And the disaggregation of network operational KPIs. How do you decide on the performance of the radio when there are distinct providers in the chain which aggregates itself to form the final KPI value? So all those topics are being worked on. There are some interesting models that are being evolved. Some of the telcos have already experimented in creating certain types of KPI and SLA governance models, and we as Capgemini, of course, are from a technology-centric system integration, service provider, have been part of this, and we continue to take several of these topics up for further discussions as really is scaling out into real world, thousands and tens of thousands to hundreds of thousands of sites. Pretty much from H2 2021, we are seeing a lot of uptick there. So some of these aspects of service assurance, team formation, etc., are becoming very real world. I have, I think, 3 minutes more. I will quickly go through and spend a couple of minutes on each of these slides. So end-to-end, what does Capgemini, and a little bit about our organization from a Capgemini engineering standpoint. Of course, system integration has always been a tradition, of course, facet of our company, but specifically in context of telco, this is not just black box system integration. As you saw, there is a lot of specification driven awareness, knowledge. How do you do the interface testing? What are the optimized configuration in which radio performances for a certain deployment can be obtained? So we provide end-to-end services in being able to do all of that, and we are vendor neutral, which means we can form the best of breed solution, taking the right container services, taking the right infrastructure services, taking the right network functions, CNFs, combination of PNF, CNFs that are needed to solve a given telco's problem statement of what they are trying to achieve, what market segment they are trying to launch ORAN-based networks going forward. Just the final slide here. Again, emphasizing Open RAN has its technology, has its all its topics that we discussed today on what's the best strategy for virtualization. But in order the RIC and XApp ecosystem work, how do you make it open? But all of this to come together, you can see it is a little complex, but the good thing is it's scientific and it can be done with the right approach. The key stakeholders are obviously the technology providers, the vendors and OEMs, the folks who presented here, the telco whose network it is, and they have their own very critical role there. And of course, the prime system integrator, someone like us, and how all of this can come together and needs to come together, and more it is coming together to really form that truly open, disaggregated, flexible, and intelligence-driven networks, which can really meet in the end, it can meet the transformation as goals there. Now, have we reached that point? There are some very good proof points of those in Asia Pacific and European networks where we have worked with telcos on that. And of course, the learning gets fed back into the operational model and how we can improve the blueprint really to go to a better stage eventually on how we can build and deploy Open RAN networks. With that, I end my session. I really appreciate again the opportunity given by the organizers, and look forward to further discussions.
Okay. Thanks a lot, Arnab Das. We had missed Sandeep earlier, so can I request Sandeep to quickly summarize the presentations from your side?
Yes. So,
please.
Sorry about that.
Very short.
Yeah. So I'm not going to cover what I have covered before. I think we just said that when we go through Open RAN, there are multiple challenges. And as we go Open RAN, there will be shift from left to right in which we become more open. So let me go to the next one. And so what are challenges I see in India? So we talked about, what global challenges could be. When it comes to India, I think a bit Arnab also captured it, but essentially interop will be a big issue. Integration will be a big issue. And how do you manage the network is going to be a big issue. So these are the three challenges apart from other challenges like auction and so on and so forth. That's where NEC thinks that if somebody can crack these three effectively, apart from product as well, would have cracked this market pretty much. So let me go to the next one. How NEC is geared, and by no means, I just want to say that probably this is the way to succeed. So NEC has a center of excellence in Chennai, where we do end-to-end solution validation. So we have the skill of plug and play of multiple CU/DU and RU to establish that. We also have a CU lab in UK, and CUE lab works with that combination. And we also have a good deal of experience in local system radio engineering, and all of it, the product OEM part, the roadmap controlled by Japan, because we have good experiences there. So again, this captures the first part, how we are geared, and rather how anybody should be geared given the Indian challenges are concerned. Now, the next one is solution integration. So right hand side, I'll just whip in the interest of time. NEC today has multiple partners, right from some of the people who speak on this call, not only from CU/DU perspective, but also from backhaul perspective, also from network performance perspective and security perspective. So we think as NEC, though we are an OEM on certain set, also have a very open architecture where all of this can come, and there are multiple global references which sort of corroborates to that. Now the next one, essentially the last part, which is very important, I think, which is automation, domain orchestration. So NEC has a flagship company on its own. It's called we are OSS/BSS company, and we also have RAN domain orchestration. And you can clearly see that the multiple challenges we talked about, right from the site engineering, site automation, also taking some flavor of FCAPS from OSS, and putting that into a product formula, which is RAN domain orchestration. As today, this will become more important as we go towards slicing, and we have Etisalat as a reference customer. But again, the idea less from the customer point of view is more that this no amount of integration will work if you don't have a proper domain orchestration. And NEC consciously is developing the software stack around it and have some domain references around it. Now, next one. Well, we only think kind of say that we are in the RU play. We are also developing 5G core. Pretty much soon, I would say not soon, in a year time or so, we should be ready for global market. The whole MANO stack and domain orchestration, and a lot of partnership for telco cloud. We think as a combination of these 5 factors, we can arrive at an end-to-end system integration, and I think that's what the need of the hour is. And the last would be, I think there are a lot of talks about how mature it is it going to fly or not? But if you look at a few incidences, and you can see the references. So today we also are present in Rakuten and expanding quite rapidly. We are part of NTT Docomo framework. We are part of Vodafone and Telefonica. We are playing a role of SI. We are also doing domain orchestration with Etisalat, and we also selected by UK government. 2 days back, Vodafone has also selected us. So the whole idea present in this slide is that I don't think Open RAN is sitting in the fences. As these leading guys go into the market and rapidly proliferate, with the likes of Vodafone, potentially all the Indian operators, we are not seeing. I do not see that. I would rather say probably it is 40 to 50%. And last but not the least, NEC is also ranked as visionary in Open RAN. So again, that's the end of my presentation. My only intention here was to say that it is a good technology, disruptive, but soon, in 2-3 years' time, I personally see that is going to increase quite rapidly. So I thank Satish and the entire team for allowing us this time. Thanks a lot.
Thank you, Sandeep, and thanks for all the speakers. This was a good summary of the overall ORAN activities happening in the industry as well as in the ORAN forum. In summary, I have some slides. I'll not go through all of them, and I'll just use this as a summary so that we can summarize whatever has gone through the period of whatever number of hours we spent here. So today morning, Deepa Tyagi had made quite a bit of remarks and comments, and some of the issues that she raised was, unlike 3GPP, which is well balanced by SDOs from different regional geographies, ORAN, is that really well balanced? That was one of the key questions. There are global geopolitics that plays out. If there is a push and pull between the vendors and the operators, that is definitely there. That is something that has to be taken into account. There was another question of, does ORAN really play out well for only for greenfield deployments, or will it also do well for the brownfield operators? That was one of the key questions which was asked. And you see in ORAN, can we go to the next slide, please? I'll just anchor on one of the slides and then, I cannot, oh yeah, I can. Okay, thank you. So I don't want to get into any of these things. So there is one aspect which is, what is openness, which would really help multiple small players or operators to get in multiple vendors to come. Vertical and horizontal interfaces. Horizontal interfaces, we have multiple interfaces between X to X and those kind of stuff. In the sense, for example, if I want to have multiple vendors come in for the RU or the DU, and that's where this plays in. And obviously, the vertical interfaces are with respect to the open front hall, as an example. And there are still issues. Even after we have ORAN specification, there's still a lot of issues with respect to realizing a technology like massive MIMO, because the RUD analog front end integrations are very tightly coupled when it comes to massive MIMO implementation. There's still a lot of interoperability issues. And again, if ORAN is supposed to solve much of the openness issues, then comes the question of, why do we still not have much of these interoperability issues, and what is the extent and scope of the interoperability test cases which gets developed in one of the working groups? That is also one of the key issues that needs to be answered. Then we have the same as the massive MIMO issue that I spoke about. Then there is this radio intelligent controller, what is this radio intelligent controller supposed to be doing? Radio intelligent controller is supposed to be enabling intelligent, to some sense, I can also say it as orchestration plus use cases which are to be accommodated, which normally are proprietary within the conventional radio access network. So is that really being accommodated? What are the serious use cases under discussion in O-RAN? There are not much of serious use cases under discussion. Even without a serious use case, there is already an interface which is getting developed between the RIC and the E2 node, which is essentially the radio access network and the radio intelligent controller. Now, what is the validation for this? Unless you have some serious use cases, this is not going to go anywhere. A serious use case, in my view, is SON, and very current use cases are bits and pieces, like, say, for example, traffic steering as one of the examples. That is what is being discussed in O-RAN today, and that is a concern. And there is also a lot that should essentially happen with, or the expectation with Open RAN. I'll skip all of these. You don't want to get to the details of all of this. See, one of the aspects that Open RAN, I'm not even getting into the issues of which of the Open RAN. There is a TIP, there is O-RAN consortium, which is trying to again standardize hardware, multiple other hardware reference designs which are being promoted by multiple of the operators. But in spite of all of this, the white box hardware is still evolving. I mean, just because it is just because it is x86 does not necessarily mean you can easily migrate between an Intel x86 and an AMD x86, and it's not that very straightforward. So to that extent, a few things will still have to be sorted out as far as the Open RAN initiatives are concerned. Then new hardwares are yet to be explored. There's still the conventional hardware that we are exploring, or the reference designs. If you look at the reference designs from O-RAN, they still very much rely on the conventional hardware. And there comes the question of efficiency and power efficiency and cost and those kind of issues, which is still to be addressed. Already existing open hardware initiatives have not been taken advantage of. Of course, nobody stops one from deploying CU or DU under OCP, which is an open consortium for hardware. But then again, there are a lot of loose ends if you really speak of a strict Open RAN-ness, unless until an operator takes an initiative and takes it in a certain direction, which is still driven by the operator. Others which are open as far as open hardware is concerned. So some of the big questions here are use cases, some serious questions, open hardware still evolving, interoperability between multiple platforms. x86 platform alone, just to take note, is not straightforward. Some things are getting worked out in working group 6 of O-RAN, but that is still work in progress, and there's convergence is one of the key factors that will take its own sweet little time. So in summary, there was also a question of security. And now, each of disaggregated or aggregated, if it is hosted within the operator premise, much of security issues does not necessarily arise, unless and until it is a shared network or some such thing. Security is not so much of a concern because operators can manage that part relatively easier. But the other questions, the pace of work, the seriousness of use cases, the emphasis and the convergence that we are seeing in O-RAN per se, the specification group of Open RAN, is still very much under question. We still have to see a lot of progress before it becomes well applicable in the 5G scenario. And it's also surprising when you have so many Open RAN initiatives, and you still need something like a G5 initiative for them to consolidate their own use case scenarios. It is ironic that you have an Open RAN initiative where much of the industry has converged, but you still have operator groups which are trying to formulate their own use case scenarios and trying to influence the open RAN community. what does that say? I mean, essentially, it says that the ORAN consortium, there are some serious gaps that still needs to be addressed. And one of the key other issue that Madam Deepa Tagi had asked today morning is, how does it help the Indian ecosystem? Does it really help the Indian ecosystem? That really has to help the Indian ecosystem. It really has to address some of the issues that we have raised here today. With that, I'd like to end this. I think it summarizes well much of where we stand from an ORAN perspective, or Open RAN perspective. It's still not O-RAN, it's Open RAN. Thank you. Thank you.
And wherein you replied, try to reply as much as possible to is raised by Deepa Madam is also on the platform. You must have heard all this.
Sashi sir, can you be a little louder, sir?
Yeah, so I'm sure Deepa Madam must have heard all this, what Satish has concluded, and he answered all your questions which was raised. So, ladies and gentlemen,